Welcome to Pratidhwani, where we try to humanize science. I am your host, G.V. Pawan Kumar. Pratidhwani is a non commercial, open access podcast, and it is available on various different platforms, including Spotify, YouTube, Apple Podcast, Google Podcast, and various other platforms. So please share this podcast with the interested. In this episode, I am delighted to introduce you to Vishwesha Guttal. Vishwesha is a physicist turned ecologist. He is an associate professor at the Center for Ecological Sciences at Indian Institute of Science, Bengaluru. He heads Theoretical Ecology and Evolutionary Biology Laboratory, which aims to probe and predict ecological behavior of individual and collective systems. His lab also studies nonlinear dynamics and patterns in catastrophic systems, and his research also includes computational approaches to study ecological systems. In this episode, we discussed how he got interested in science, what motivated him to study physics, and then switch to biology. Specifically, Vishwesha tells us about his experience as an undergraduate at IIT Kanpur, where he did his integrated masters in physics. He mentions how he developed interest in statistical mechanics, nonlinear dynamics, and related areas, which further introduced him to research problems in biology. Then we discussed his experience of moving to United States as a PhD student, where he initially started his research in condensed matter physics, but gradually shifted to physics problems related to ecology. This essentially indicates an interesting phase transition, so to speak, in his career, which further paves the path for him to develop a deeper interest in biology and ecology in particular. Vishwesha also tells us about his current research interest and what kind of problems his lab is studying now. His interdisciplinary approach to solving problems is worth listening to and has some very interesting clues for people, including students and researchers who want to go in that particular direction. We further broadened the scope of the discussion and talked about how teaching can influence critical thinking and also influence people to become better researchers in general. An interesting part of the discussion was to talk about fatherhood and how it has influenced Vishwesha in maintaining work-life balance, which is really worth listening to. There's also an excellent segment in Kannada where we discuss about his motivation and research, which is fascinating, and I would strongly recommend you to hear that. Overall, the conversation has so many interesting strands and branches that each path we took during the conversation is worth exploring by itself. I'm sure you will gain a lot of insight listening to the whole conversation, which, by the way, spans over 2 hours or so. This is Pratidhwani, where we try to humanize science with Vishwesha Guttal. Namaskara, Vishwesha Guttal. I'm delighted to have Vishwesha on this episode. Welcome, Vishwesha.
Thanks, Pawan. Thanks for having me. I really appreciate you calling me for this recording. I'm looking forward to it. Huh?
My pleasure. My pleasure.
One
So,
small correction. Can I tell you one small correction? This is a
yes,
mistake. Almost everyone does.
yeah.
Okay, my last name. My
Ah,
last name is pronounced Guttal.
Guttal. Okay, Vishwesha Guttal. Guttal. Oh,
Guttal, yes.
yeah. So
Guttal
tell
is
tell us
a
tell us where is Guttal? Is that a place?
yes, yes. So there are two places
Ah,
with the same spelling. One place is near Haveri, in Karnataka.
mm,
It's
mm.
Guttala is the Kannada version, and anglicized version is Guttal. Okay.
Okay, okay.
Okay.
Nice, nice.
And there is another place. If you search in Google, you will find that it's a place in Austria. Okay.
Oh, that's very interesting. That's very
So,
interesting. Okay.
but as you can guess, I'm from the Guttal of Haveri district in Karnataka.
Uh, Averi district. Very nice. Very nice. Excellent. Excellent. So, Vishwesha, please give us an overview of your background growing up in your household. Where exactly were you born? Tell us a little bit more about your background. and how you got interested in science.
Okay, yeah.
Hmm.
So I was born in North Karnataka,
Hmm.
in a place near Gangavati,
Hmm.
where my father was working at that time.
Nice.
Okay, and then my father moved around to Ballari first, followed by Bengaluru. By
Hmm.
1987, he had moved to Bengaluru for his work. He was working in the government sector, agriculture department.
Nice.
Okay,
Nice.
and I think his work was more based on the field work,
Hmm.
advising farmers, and then eventually switched to at the secretarial level to the government.
Okay. Okay.
Okay,
Nice.
so and
Nice.
then so we also moved here, and then since then we have been here, uh, since 1987, and by then I was in my second standard. By the time we
Hmm.
moved, so it was already I was in second standard. So I did my schooling all the way from second to 12th
Hmm. Hmm.
in various schools and colleges in
Nice.
Bangalore.
Nice.
And yeah, so and that's where towards, and as you know, towards the end of your 12th or PUC is when you have to decide
Hmm.
what to
Hmm.
do. What kind of career you want to choose, and like almost everybody else around me, the
Hmm.
most obvious choice would have been to take up engineering.
Nice.
Okay,
Nice.
and that also seemed like the right thing to me at that point of time. And all else being same, I think I would have done that.
Yes.
Uh,
Yes.
but it so happens. So now, of course, how did I then, if you basically almost all sort of things around me would have led me to take up engineering.
Hmm.
But there were some small anomalies, if I can use that word. One is that my brother, was already a trained engineer by then.
Nice.
He's
Nice.
6 years elder to me,
Hmm.
and by the end of his engineering, he realized that engineering is really boring.
Hmm.
Okay, and then and so he thought that, I mean, I think maybe he wanted to. He realized that maybe he should have studied science. Okay,
Ah. Okay.
and then he, from ninth onwards, no, when I was in ninth, he was midway through his engineering. When I was finishing my 12th or second PUC, he was already in a job. So I think his experience that of what could science have been and what is his experience in engineering education,
Hmm. Hmm.
uh, I think then he tried to sort of slowly inspire, why don't you consider taking science? And of course, like everybody else, in a sort of, middle class family at that time would be worried that, okay, what about the financial prospects and jobs after doing a science degree, right?
That's right.
Uh,
That's
but
right.
but he also knew that degree alone doesn't mean much
Hmm.
as long
Hmm.
as you do well. And I think, and I was also convinced with that point. Let's say if at all I end up not liking science or not doing well, I can always switch to engineering because the number of jobs are really remarkably huge in engineering, and it isn't too hard to switch to, especially the IT field, which was
Hmm.
in boom then, which still is in boom today, right?
Absolutely.
In
Absolutely.
different forms.
Yes. Yes.
And then, and if you actually think about it, there is really no good reason for somebody to be strongly interested in engineering
Yeah.
by the end of their high school,
Hmm. Hmm.
because none of our curriculum really exposes to any engineering. In fact, we only do
Absolutely.
science, right? So, in fact, the most natural thing for most students must be to be actually interested in engineering,
Easy. Yes. Yes.
except for the fact that almost a large part of students and families, in fact, it's not really a student's choice per se, right? The
Yes.
family's
Yes.
choice of career for their children often is driven entirely by jobs, right?
Hmm.
Which is
Hmm.
why, engineering and medical fields, and maybe now there are more, I don't know, are sort of, by default, the choices that their kids want to pursue, right? The families want their children to pursue. So if you go entirely by what students are actually exposed to, the most natural thing is at least a good fraction of them must be really interested in science. Because by the end of 12th, uh, especially those who do continue for science in 11th and 12th, or
mm.
even PUC, they would have been really exposed to really good amount of science.
Science, you're right.
Basically modern physics and fairly modern mathematics, right?
Mm, mm.
So to me, that seems to be the most natural thing. So in fact, I
Natural.
was also got interested in science by the curriculum itself.
Mm, mm,
Although everybody says our curriculum is really bad and so on and so forth,
mm,
among all
mm.
the subjects, I really liked physics and math. Okay.
Nice, nice.
And then I was also luckily encouraged by my brother to take up science without any hesitation. And luckily, I also uh, got into the sort of kind of environment I wanted to be in. So
Mm-hmm,
things worked
mm-hmm.
out in terms of both encouragement from the family as well as the opportunity that I got.
Nice,
So
nice.
that sort of led me to science.
Science, very nice, very nice. So, in terms of the kind of upbringing what you had, it looks like you also had a reasonably good ecosystem within your house, where there was enough freedom for you to do whatever you want. And how was your schooling kind of experience? Was it enjoyable? And what is your general opinion on the schooling process itself?
Uh-huh. Yeah,
Especially
luckily.
growing up then. Yeah.
Uh-huh. Yeah, like, luckily, I absolutely had like zero pressure to do, in certain specific way from my parents at all.
Yeah, yeah.
So I don't think they really bothered how much marks I got and
Mm.
how I was doing throughout my schooling, all the way probably up to 12th. I don't think they really ever worried.
Okay.
And so I come from a very orthodox family, and they were always interested that I also learn a
Mm,
lot
mm.
more other things than just be interested only in science.
Nice,
So they
nice.
wanted me to learn Sanskrit. They wanted me to learn various spiritual texts. They
Mm,
thought that
mm.
just running behind modern education just for the sake of job is not the right thing to do.
Right, take it. Yes, yes.
And so in some sense, so that the importance of education for the sake of education and
Mm,
learning
mm.
was sort of deeply part of my family.
Family, very nice. It's very interesting. In fact, it also kind of gives you an interesting foundation, because this is something consistently being observed with a lot of people with whom I'm conversing, is that no matter what is the background of the parents, they want their children to be very well educated. You can also see the reinforcement of the fact that education is so central to whatever we do.
Mm.
So, in that sense, how was your schooling kind of experience? Where did you go to school in Bengaluru? Mm,
Yeah.
yeah.
So my
Mm.
primary education was in a school called Bharat Mata Vidya Mandira. It's a Kannada
Mm.
medium school. So
Ah,
I up to
in
seventh.
Bangalore.
Yeah,
Oh,
yeah.
interesting. Very nice. Okay.
Yeah.
Mm,
So this
mm.
is in South Bangalore. So that's
So,
where I went up to seventh class.
nice.
And there, again, it was very leisurely. There
Mm,
was
mm,
really not a huge pressure. I think I enjoyed my learning by and large.
mm, mm.
And so I never really, because I think that the fact that the education was also in my mother tongue, I think it really helped me in the obstacle of language to learn was not a part of at least the early education. Of course,
Wonderful.
once kids pick the language, say even if you study in an English medium language,
Mm,
after a
mm,
few years you will pick up the language well and to continue to do well. But for example, I see with my own kids now that if I don't help them on the
mm,
language part, they are in second class now.
mm, mm.
They cannot learn on their own. Okay,
Yes, yes,
it
you're right.
becomes quite difficult for them.
Mm,
Okay,
mm,
so
mm.
whereas that was naturally not a part of my upbringing and education. And also the concept of homework and all
Mm,
are
mm.
extremely alien to my school. So whatever happened in the class happened in the class, and once we went home, I don't think there was almost ever a homework, and even if there was one, I don't remember right now.
Right.
If there wasn't That was in the
Wonderful.
primary school, and that continued in the high school. High school
Mm.
was, so this is Vijaya High School in Jayanagar in Bangalore, and that's a
Bangalore.
very
Yes.
reputed school.
Yes. Yes.
And there again, now it was in some sense uh, a different sort of a very different school, in the sense that there was a very high expectations of students doing well in that school. But
Nice.
because the class sizes were massive, like, I was one out of 90 in my class, the teachers could, of course, never pay attention to any individual, which
Yeah.
is really great. So because
It's a blessing in disguise.
yeah, so I never had to be in the limelight. Okay.
Yeah.
I really like that. And also because I now came from Kannada medium to an English medium, I had
uh,
a lot of initial difficulties in the first 2 years
mm,
to
mm.
adjust to an entirely new environment in terms of the language to learn. Okay, and by
Nice.
I think mid 10th standard, I was sort of okay with that. I was comfortable.
Mm, mm. It's
So, so I was good.
wonderful.
It was good to be out of the limelight. Of course, there were really top students who were in the limelight. But even
Mm.
then, again, I don't think we ever had homework. But there were more regular tests and so on and so forth.
Nice.
In high
Nice.
school, the fact that there were no homework, and again, no sort of very individualized pressure.
Mm, mm.
I think that was really helpful.
Okay.
Uh,
Okay. That's very interesting. Because the traditional schools like Vijaya High School and various different national
High school, yeah.
college,
Mhm.
also that is a kind of a lineage, right? Because
Yeah,
generally
yeah. That's
people
where I went to Indian next.
exactly, because most of the time that is the linkage always, especially if you live in South Bangalore. That is the way you generally kind of progress, and that is also a time. This is, I think, you are talking roughly in 90s, early 90s,
Late 90s.
late 90s, late
So
90s.
I finished, I joined, I don't know, when I finished my PUC by 1998.
98, yeah, 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 exactly. that's
98.
that's roughly the time. So that is also a very interesting time, because in Bangalore, a lot of IT is evolving. There would have been a lot of pressure on you to really go and do information technology based engineering, and then you probably proceed from Vijaya College, Vijaya High School to National College
Yeah,
for your
National College
PUC.
in Jayanagar.
Mm,
Yes, yeah,
mm,
yeah. So National College in Jayanagar,
mm,
and then again, it was again I sort of ideal kind of college for me. I
mm,
don't think
mm.
there was ever attendance taken properly. I mean, I think they
Ah.
take occasionally, which was sort of good, good enough. And then the college timings were sort of quite leisurely,
Leisurely, yeah.
and there was a lot of time for self study.
Mm, mm.
Which, and I think I realized that I really enjoyed doing math somewhere around 10th.
Ah,
Okay.
nice, nice.
So, and then, so by then, I was sort of very comfortable just solving,
Hmm.
reading a book and solving problems entirely, almost entirely on my own. Okay. So
Nice.
that really, and the college structure really gave that
Mm,
room to do that self study
mm, mm.
without having to be driven by an extremely sort of strict, rigid regime in the college. So that was very helpful. And I also had a
Interesting.
good sort of company of students,
Mm,
other friends
mm, mm.
who were like minded, and we would also study together a lot.
Wonderful, wonderful.
So that really, again, that peer group was also really, really helpful to have.
Fantastic, fantastic. So now, see, one of the unusual transitions,
Mhm.
because having personally also experienced similar kind of education, albeit in the northern part of Bengaluru, what I see is that you made a shift to IIT, IIT
Mhm.
Kanpur, right? Right after your 12th standard.
Yeah, 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 yeah.
And tell us that transition, because that is actually quite a large jump, because
Mhm.
most of the time, especially in the Kannadiga community, if you are from Bengaluru, RV College and BMS are the benchmarks to really move into.
Yeah, yeah,
But what really motivated you to go towards IIT Kanpur? And of course,
yeah.
Kanpur reputation is very very high, especially in 1990s. and early 2000s. It was probably one of the go-to IITs, right? And
Hmm.
could you please tell us that transition, Vishwesha?
Yeah, so that's
Mm,
interesting because when I finished my PUC, so I had like two choices based
mm.
on my CET ranking. I could have taken the BMS college, I know, well, let's say computer science or electronics or one of these kind of
Yeah,
branches,
yeah.
which is 2 kilometers away from my home.
Yes,
Okay.
exactly,
Now,
exactly. Uh,
the contrasting option was, I had, when I had gone for IIT counseling, I
mm,
had primarily chosen, science subjects,
mm,
and then I got this physics in IIT Kanpur. Okay,
mm, mm,
and IIT Kanpur physics department is particularly well known,
mm,
and so the choice was, should I do this, normal sort of, sort of, career
mm.
trajectory of what, as you said, most Canadians would have done at that point of time,
Yes,
to
yes.
take, especially if you got a seat in BMS or RV college, you should just take
Oh,
anything,
yes, yes.
and that too if it's only 2 kilometers from my home, as against a
Absolutely.
place 2,000 kilometers far away, where I had never been on a train until then. By the way, I had
Wow.
I had never traveled on a train up until I was 17. Now I had to spend 2 days in train going to Kanpur.
Kanpur.
So that was sort of, and I had never traveled outside Karnataka.
Yes,
Uh,
yes. Okay.
so so that was, how, extraordinary dilemma, and I think it was not an easy decision. It was
Mm,
an
mm,
incredibly difficult decision in terms of the location, distance,
mm.
and also the unusual choice of subject.
Yes, yes.
Anyway, I mean, after a lot of deliberations and thinking, and
No, but I think
uh,
probably a major credit goes to your parents,
yeah,
Be-
absolutely, yeah,
right?
absolutely, yeah, yeah.
Because
Parents
this
and
is
brother,
really
yeah,
requires the kind of peer pressure they would have in sending
yeah.
off their kid to do a master's in physics, or rather integrated masters in physics,
Mhm.
vis-a-vis something like an engineering degree in within the comfort zone of Bengaluru. I think that is a remarkable decision to make, right?
Actually,
Because
I don't think they really had any issues with the subject. Their only concern was the distance.
distance.
Uh,
Wow,
yeah.
wonderful, wonderful.
So I mean, they said, okay, then why don't you just? I mean, they were like, why not just take, let's say, National College BSc? They would be
Mm,
totally fine with that.
mm,
Okay,
mm, mm,
instead of going so far,
mm,
their
mm.
concern was really the distance and location rather than
Location. Yeah, yeah,
subject at all. So yeah, you're right, absolutely right. But they had absolutely no worries or concern about the subject or the
yeah, yeah.
degree that I was going to get. Yeah, but
No,
it was a tough decision for everyone, and eventually we took it. Uh,
wonderful, wonderful. In fact, I wish more parents, especially living in Bengaluru, kind of listen to this. This is an
mhm,
important part of it. I am very sure it would have been also driven by your own interest, because otherwise, without that self motivation to really send off a kid at that junction to do something which is like physics, would have been a slightly difficult choice to make. Yeah,
yeah,
wonderful,
yeah,
wonderful.
absolutely. Yeah.
So, Vishwesha, how was your experience in IIT Kanpur? Like, of course, as you mentioned, there will be a little bit of cultural kind of change
Mm,
and also language. Uh,
mhm.
Paint us a picture of how was your experience there.
Yeah, I think it was a very interesting experience. Of course, uh, so I think there were that, and there were sort of two types of experiences I can sort of I remember well in terms of the choice of subject.
Mm, mm,
Okay, so now uh, the sort of, for most students, right,
mm.
across the country, right, the first thing you should do is to opt for an engineering degree.
Yeah.
Okay,
Oh, yeah. Mm.
only when that option is exhausted, right, you should really
Exactly.
be for other things like, physics or
Yeah.
MSc or
Yeah.
BSc, whatever, right? So now the although you are, although everybody comes from this background, and that although you would think that although everybody comes from this background, once they are in IIT, they realize that life is a bit different,
Life
right?
is a bit
The way you
exactly.
think about subjects should be a bit different, is
Absolutely.
what one would think. But I was remarkably surprised that despite that, a large number of students, even after spending several years in IIT, don't realize this. That
Mm,
they
mm,
realize that taking a pure science is a mistake.
mm,
Oh, why would anybody do that? You must be extraordinarily stupid
mm,
to be
mm,
doing
mm,
something like this, especially
mm.
when your rank allows you to take a different engineering subject.
Absolutely.
Okay, and so in fact, one of the questions that I would get asked, and also I would say got bullied
Mm.
for, why did you choose this subject? Are you an idiot? We have
Yes,
done
yes.
this from a lot of seniors.
Absolutely. Absolutely.
Not so much among my own peers, surprisingly,
Mm,
but
mm,
so much, lot more among my seniors who would, meet juniors for the first time.
mm, mm.
So,
In
and
Kanpur, you mean to say?
only, yeah, in IIT Kanpur, exactly, yeah, in IIT
Oh,
Kanpur.
okay, okay, okay.
And I think that really increased my resolve and
Mm, mm.
conviction of why I have chosen is the right
Absolutely.
thing. Uh,
Absolutely.
and how a large proportion, a really, really large proportion of students who join IITs choose a subject entirely based on rank without giving a single thought of what is truly interesting to them.
Mm,
Okay.
mm.
And the fact that even after spending several years they don't think about it. I can
Think
understand
about
that
it.
they haven't thought about this when they join,
Mm,
but the
mm,
fact that a lot of students probably don't even realize, at least at that point of time, maybe things have
mm.
changed now, I don't know, that they didn't realize it even after spending several years, was really, really a bit of a shocker to me. That everybody follows, herd mentality, if I can use
Mm,
that word.
mm.
I
Absolutely.
mean,
Absolutely.
ironically, I study herds now in animals, herding behavior in animals. I'd speak
Nice,
to people
nice.
who study herding behavior in humans also, but although
Nice,
I don't
nice.
study herding behavior
Uh,
in humans. But I think that that herd mentality, or that, oh, everybody must be choosing engineering by default, and
ah,
anyone who doesn't do it must be an idiot. I
mm,
think that
mm,
thinking that was so prevalent was really a bit of a shocker to me. But on the positive side, that really, increased my own resolve and conviction of why, what I have chosen is
mm,
actually really interesting to me, and I shouldn't really worry what they are saying,
mm,
what they are
mm.
saying, and what they are thinking. Yeah,
Very interesting. Very interesting. So, which means that the overall ecosystem within Kanpur was mainly dominated by engineering, or was there also?
absolutely,
Uh,
absolutely. Yeah, 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 yeah. But again, luckily, my own batch in physics was really, really good,
mm,
and many of us were truly interested in pursuing physics,
mm.
and that's why we had joined physics, not
Yes,
merely
yes.
because
Yeah.
our rank destiny led them to
Destined.
this.
Exactly. It's not like you do not have any choice and therefore you're
Yeah,
taking
yeah,
this
yeah,
up or
yeah,
something
yeah.
like
So
that. Yeah. Yeah.
it was a really small batch of just 10 students, but
Good. Good.
almost everyone was really interested in
Mm,
understanding physics, learning about physics,
mm,
and in fact, as of today, and that is sort of very clearly indicated by how many of us of in
mm,
that small batch are actually
mm.
still continuing to pursue science.
Okay.
One of my friend is faculty in IISc, another one in uh, another a few, roughly about 4 or 5 of the us in a small batch of 8, I think, who
Mm,
graduated are
mm.
actually in academic positions in India right now.
Okay. Okay.
And others are also doing science in different capacities. So all
Mm,
of all
mm.
of us are chose physics because we were really interested, and we pursued throughout in those 5 years
Five
because we were
years.
interested. Of course, some for various reasons may have slightly different way, but every one of us in that batch was really very keen to learn science, and that really made us a really nice group of uh, peer group, and made sort of process of learning very enjoyable.
Wonderful. Wonderful. This is actually something very, very interesting also. So, in terms of the exposure to slightly more advanced topics in physics at Kanpur, so how was your experience? What did you kind of uh, get interested in? Could you please tell us?
Mhm. Yeah. I think that's really interesting. I think in the sense that the topics I chose over time, I think that's the trajectory. I myself find it very interesting.
Very
So
interesting. Yeah.
of course, when you join for any subject, you only have a very naive understanding of what it is, right?
Yes, yes,
And because you are only exposed to basics and not really any advanced topics. and
absolutely.
um and then of course, like in the initial years, the sort of standard physics stuff is all we
Mm,
learn. We learn
mm,
classical mechanics, we learn basic thermodynamics. We learn more of what modern physics in a slightly advanced fashion,
mm.
optics, and all these
Yes.
topics come in, right?
Mm,
And
mm,
then I think by the end of third year,
mm.
I actually started finding these subjects really, really boring. Sort of,
Ah,
the conventional but classic subjects.
ah,
Okay.
ah.
In fact, the only interest I still had by then was actually maybe mathematical methods in math. I sort of
Nice,
didn't
nice.
like physics anymore by the point of time. Okay.
Very interesting. Oh.
And I thought that, oh, maybe I don't know what, maybe there may have been a combination of that,
Mm,
various things. One of it was that I felt, at least my feeling at that time was, the physics itself was taught in a way
mm-hmm,
which I
mm-hmm,
think, it's a sort of maybe retrospective,
mm, mm, mm,
understanding of that scenario.
mm-hmm,
Okay, was actually more driven by applied math,
mm, mm.
rather than the physical intuition.
Very correct.
Okay,
Absolutely, yes.
a large
Absolutely.
part of the
Yeah.
teaching at that time
Mm,
was that, be it classical mechanics, be it quantum mechanics,
mm, mm.
and be it even thermodynamics, maybe to a lesser extent thermodynamics, but
Absolutely.
more so of
Absolutely.
conventional topics like classical mechanics, even
Mm,
electrodynamics. Okay,
absolutely. Absolutely.
basically you're sort of solving, once the problem is set up, you're basically solving lots of equations one after the other.
Absolutely.
And
Absolutely.
I felt that, I think now in retrospectively, this is a retrospective analysis. I didn't
Mm, mm,
understand back then. I think the
mm,
main reason for this was maybe I did not understand it, or they didn't do a good job. Let's leave
mm,
that aside.
mm,
Whatever
mm,
might have been the actual reason. I think
mm,
the
mm.
problem setup itself was not clear to me at that point of time.
Yes.
Okay.
Yes.
So that
In
was
fact,
sort
I
of.
should mention that this retrospective viewpoint actually is very accurate. One
Hmm,
of the issues why a lot of students do get kind of slightly deviated away from physics, especially those who may want to really build an intuition and even branch into experimentation,
hmm,
is that if you're reducing all problems only to a slightly more mathematical machinery viewpoint, nothing wrong in it, because there is
hmm,
a lot of value in one of the aspect, but you're losing out a lot of other things.
hmm,
In fact, personally, having been also teaching physics, I
hmm,
can see that what you're mentioning is absolutely right. In fact,
hmm, hmm.
please go ahead. Please go ahead.
Yeah. So you see,
Mm,
if I go back and think,
mm,
what
mm,
was it that made me interested in science was, the at least up to the high school level, the problem setup was given sufficient attention. I feel,
mm,
even in our
mm.
conventional textbooks.
Absolutely right.
Okay,
Absolutely right.
and
Yeah.
certainly one physics teacher that I who taught who
Mm,
taught us, made that very sure. In fact, the only coaching class I went to in my PUC
mm,
was physics. Okay,
mm, mm,
I did not go to math and chemistry,
mm,
and it was Professor R.K. Jagdish, was a
mm.
former teacher in National College. He was
Nice.
conducting these private tuitions for PVC and CET, and he not only solved problems, but he also made sure the context and the sort of
Mm, mm,
the physical context for it was sufficiently clear. It was not that he would go on telling a lot of stories. He was actually considered very serious teacher, but he
mm.
made those contexts from a physics point of view, I think, very clear. Okay, and I think, and of course, I was also on the side reading wherever I could some a few passages from Feynman's lectures. and
Wonderful,
also
wonderful.
even Resnick Halliday book.
Analysis. Yes,
So
yes.
where again, the context of the physics problem
Mm.
is extraordinarily well set up,
Well set up.
and the
Absolutely.
philosophy of solving problems has a you know, huge sort of component to these sort of approaches in both Resnick Halliday as well as in Feynman in some sense. Feynman a lot more, right?
Yeah, yeah.
Resnick Halliday is more problem driven, but the
Problem
context
driven.
is
Yeah,
clear.
yeah.
Okay, now I think that I felt was absolutely lacking. Okay,
Mm, mm,
so maybe giving a benefit of doubt to my excellent teachers, I can also say maybe I didn't get that very well
mm,
because a couple of other students seemed to do better. Okay,
mm,
so
mm,
maybe to me it wasn't very clear.
mm, mm.
Okay, so in some sense, by the end of third year, I had lost that interest.
Interesting. Okay,
And
okay.
okay, and but because I was always interested in math, the math part was still interesting to me. I never had
Yeah.
math part I never really had a problem with it. I
Mm,
still like the
mm,
math part of it. For example,
mm.
just writing simple operators, solving nicely one after the other. But okay, all that is fine. But I did not see physics connection in any of those.
Exactly. In fact, you can get away doing a lot of good math without understanding any physical intuition at all.
Right?
This is again very true. What you're mentioning is very correct. Yeah.
Okay.
Mm.
I mean, it was not that my grades were suffering or anything. They were okay, reasonable.
Exactly. Exactly. No, because anybody who is well versed and comfortable using mathematical methods, even in a reasonably advanced degree in physics, can survive. And I agree with you. Absolutely right. Absolutely right. Yeah.
Okay. So, but now there was, of course, one exception to this.
Mm.
The one exception to this was the statistical mechanics course, which was
Uh-huh. Uh-huh.
something I really enjoyed. I think it was at least taught in a way that really appealed to me.
Very nice.
Where the mathematics, of course, is inescapable in statistical mechanics.
Mm.
Actually, a new
Mm.
type of mathematics. If you really
Yes.
think about it, you actually now solve in very different ways than
Absolutely right. Absolutely.
typical classical mechanics, quantum mechanics, or but the context I thought was extraordinarily well set up.
Mm. Mm.
And this was Professor Debashish Chaudhary who taught us this course,
Yes.
and I
Yes.
liked statistical mechanics. Okay, did reasonably okay, not much,
Mm.
not substantially better than any other course. In fact, I think I had better grades in other courses which
Mm.
were more
Mm.
mathematical.
Mm.
Okay,
Mm.
and then he also in the fourth year, by the end of third year,
Mm.
I was okay. I'm not finding all this very interesting, but I have to finish anything anyway. I also bought a computer at that point of time.
Mm.
Okay,
Mm.
so to play around with coding, and then in the fourth year, so I still had 2 more years of
Mm. Mm.
of physics courses left, right? So in the fourth year, there were even more advanced courses. Okay, and one
Mm.
of which was a course on advanced statistical mechanics. It's an elective
Yes.
course.
Yeah. Yeah.
Okay, now that again was taught by the same professor, Professor
Mm.
Debashish Chaudhary, and I found it incredibly interesting.
Mm.
Okay,
Mm.
and I realized that that's one topic where I could not. I also not found very interesting, but I also could perform very easily, very well.
Mm. Mm.
Uh,
Mm.
you know, and I also like the principles, philosophy behind it,
Mm.
and as well as the way it was taught and the way I was doing. And there was also a project in that course. Okay,
Nice.
and the project again got me really interested in how non-equilibrium statistical mechanics is something that's a lot more appealing to me. Okay,
Nice. Nice.
and I also have was learning some. Of course, I had learned some amount of coding in other courses, but I was
Mm.
actually now using that for some for some problem in non-equilibrium statistical mechanics. Now, by the end of third year, I had almost made up my mind that maybe physics is not what I would continue. By the end of the first semester of fourth year,
Ah.
I sort of began to see that okay, things actually could be different if this is the kind of that I can continue to do.
Nice. Nice.
Okay,
Very nice. Mm.
so the non-equilibrium statistical mechanics, the exposure to that was, I
Mm.
think, sort of the main, sort of turning point. That sort of again got me back interested in a not a superficial way anymore. I think in a very sort
Mm.
of deep way to me.
Deep, deep way. Yeah.
Yeah.
Very interesting, Vishesha, because see, if you look at it very carefully, statistical mechanics and more so non-equilibrium statistical mechanics connection to branches other than physics is very, very wide. In fact, so wide that it sometimes becomes ubiquitous, and it doesn't get registered, right? Because if you look
Mhm.
at the scale of the problems you can
Yeah.
tackle, is
Mhm.
tremendously broad. In fact, somehow, in if you look at traditionally in physics education, especially at a master's level, it is a quantum mechanics which, and of course general relativity and other things really dominate,
Mhm.
and to a large extent deservingly so, because it has created literally revolutions. But somehow, in the glory of these topics, the
Yeah,
statistical mechanics somehow doesn't get the emphasis. And I'm very
absolutely.
glad
Yeah, yeah, yeah.
that you are actually a real example of the person who has taken that interest and gone on to do something very interesting. Yeah, so please go ahead, please go ahead, tell us more about that aspect, please. Yeah.
Yeah, yeah.
Yeah.
So yeah, you're absolutely right. I think
Mm.
and again, if you think about it historically, the
Mm. Mm.
non-equilibrium statistical mechanics parallelly developed, sort of was founded by the same person in some sense.
Mm.
By the person who also developed relativity, right? Einstein was the one who
Exactly,
laid the
exactly.
foundation for Brownian
Foundation.
motion.
Yeah, Brownian
And
motion,
Brownian
absolutely.
motion
Yeah,
sort of becomes the foundation for the non-equilibrium
absolutely.
statistical mechanics as well as the mathematical counterpart of which is stochastic calculus. The
Yes, yes.
entire branch of
Mm.
probability sort of
Mm.
developing in a really rigorous way was largely inspired by what Einstein did with Brownian motion,
Absolutely,
right?
absolutely,
And the
absolutely,
mathematicians take it in a very very rigorous way on the mathematics side of stochastic processes, and on the
absolutely.
physics side again a lot of developments happen, but
Mm. Mm.
slowly, but again very important developments over the next half a century, right? uh,
Absolutely,
and so it's interesting that both the topics actually came from the same person, which is really
absolutely.
remarkable.
Remarkable, remarkable. That's
uh,
truly amazing. You're right. Yeah.
and I think then, okay, coming back to statistical mechanics,
Mm.
my
Mm.
understanding of
Mm.
non-equilibrium statistical mechanics, I had also done a course in the second year of my MSc program, second year of my
Mm.
5-year MSc program, a course, an elective course on nonlinear dynamics.
Yes, yes.
Okay,
Yeah.
now again, um, I now teach that course, and there were some elements of it back then. I absolutely loved it.
Mm.
Okay, but
Mm.
as I said, unfortunately, again, the way the course was taught was like a mathematical machinery
Mm.
rather than the extraordinary beauty of nonlinear dynamics.
Yes, yes.
And then I realized by the sort of by the completion of my MSc program that how these are all sort of intricately linked,
Mm.
the
Mm. Mm.
nonlinear dynamics as well as sort of the non-equilibrium statistical mechanics. And so that's how sort of my sort of interest in physics took a sort of interesting turn. And uh, and then, as now it is not just that I'm now doing, for example, non-equilibrium statistical mechanics in a pure formalism way, right?
Mm. Mm.
I now study biological systems,
Absolutely.
and one can ask what is the connection,
Yeah.
or how did I get interested into that direction of research. And again, that began during my that course that I told you about on equilibrium statistical mechanics. So there was a project that we had to do in this course, and I was trying to look for topics, and our
Mm.
professor had suggested various topics for studying for the project, and I wasn't sure what to pick. And I remember I was standing in front of his sort of, I had a meeting with him, and I was waiting for his
Uh-huh.
another meeting to get over. And he
Uh-huh.
has
Uh-huh.
this board outside his office where he has put various papers,
No.
or
Oh.
recently published papers. So there was this
Okay.
paper that was published just 1 year before, and it was a
Uh-huh.
review article on non-equilibrium statistical mechanics of traffic phenomena. Okay.
Ah.
So I
Uh-huh.
was reading the abstract of it, and I found that interesting. It was trying to basically sort of model
Mm.
vehicular traffic
Mm.
as an non-equilibrium transport phenomena. Okay.
Wonderful. Wonderful.
So, and while standing waiting outside, I had read the first two pages which were pasted there. Okay.
Ah.
And I went and told him, why don't I do a project on that. The expectations of projects are fairly modest. You
Ah,
sort of
ah,
learn a good paper and reproduce some basic results and see if you can come up with your own extensions. Okay.
wonderful, wonderful.
So my course project basically then became
Hmm,
sort of reproducing some basic results of
hmm,
traffic flow, non-equilibrium statistical mechanics of traffic flow. So I did some coding and did some coding of how vehicles move and how we can
hmm,
they construct something called sort of an equivalent of phase diagrams in this phenomena, and I was able to
hmm.
do that, and I found that really really interesting again. And then
Wonderful.
as a follow-up project
Hmm,
beyond the class, when I was discussing some possible problems, we were
hmm,
discussing, why don't we study, just like this was basically a mathematical, you can think of what I was doing for the course was, how vehicles move sort of
hmm,
in an idealized setup where there's a line. You
hmm.
can't move away from there. You can only go in one direction on the line, and then
Yeah.
and how does the number of vehicles on the line affect the traffic flow? That was the question we were interested in that
Yes. Hmm,
traffic flow problem. But then we thought, if you think of animals like
hmm,
ants, they also
hmm.
form lanes,
Very nice. Yes.
right?
Yes.
They are also very, very dense lanes. And if you now
Hmm,
think about from the models that were there at that time, such
hmm.
dense lines must actually have traffic jams. Okay.
Uh-huh.
Now, how is it that ants don't have traffic jams?
Hmm,
Okay, why
hmm,
don't they get
hmm,
stuck? What is
hmm.
it different that they are doing? Okay, so basically my which then became my first research project was to sort of work on a model of ant trail formation.
Interesting.
Okay, so
Hmm,
a simple non-equilibrium statistical mechanics inspired model of how ants form trails and what is it that is different from ant trails that is different from, let's say, a vehicle lane. Okay, so that was my first sort of foray into sort of looking at the interface of non-equilibrium statistical mechanics and biological systems.
wow.
Uh,
So, Vishesha, this is a very unusual, even especially unusual for that time, where students are really trying to kind of get interested in a slightly offbeat topic in physics itself.
mhm.
Uh, of course, a lot of credit should go to Professor Chaudhary because he is also probably motivating students to really look into such problems. But how was your ecosystem? I'm a bit very kind of very interested because the peer system would be there are for example astrophysics, other things, even experimental side people would be really thinking something else altogether. And IIT Kanpur traditionally also has very strong, solid state physics kind of the tradition, and also some optics and other kind of stuff. So, how was this thought process? Because this is very important, right? Because a lot of students face this dilemma, especially around MSc to further kind of junction. Can you tell us? This is a kind of a really bold decision. Also, you're taking. Uh, Please tell us a little bit more about this.
Yeah, I think that's a really great point. So I think you're absolutely right. Just as the choice of engineering and physics is a tough choice, right?
Yes. Yes.
On in the peer pressure context, so is the choice within the physics discipline.
Absolutely.
You're absolutely right that sort of the glamour associated with string theory or high energy physics
Exactly.
doesn't
Yeah.
exist for condensed matter physics. And even
Yeah.
within
Yeah.
condensed matter physics, topics like superconductivity, superfluidity
Yes.
were really hot topics,
Yes. Yes.
back
Yes.
then. And
Yes. Yes.
then, I remember very funnily, a lot of my friends would make fun. We also used to speak Hindi, right?
Ah.
वो चीटी
Yes.
पे चीटी चीटी के ऊपर काम करता है तो क्या कर रहा है but in a very funny way, they were all really good friends. And, I think,
Yeah.
again, I have to say a lot of credit to my peer group back then. I
Mm,
think we
mm.
were, we were really incredibly open minded and,
Banded.
appreciative of
Yeah.
what everyone did. And again,
Wonderful.
it was really the funnier comments always came from the engineering side of it. Okay, not only are you doing physics, you're not doing physics, you're studying ants now.
Oh man, that is
So,
usually a brutal pressure.
so, but at the end of the day, luckily, I was able to pursue what I thought was very, very interesting back then.
Uh-huh.
People would also say, you are choosing an easy way out because these are not much competition in this field. So,
Uh-huh.
my field is better than yours because it's more competitive, more
Yes.
difficult. But I think all these things were there, but I think they were all at a very mild level, but never I think in a maybe I was good in ignoring them
Yeah,
also.
yeah. No, that
And
that
that
comes
combination.
also that comes from kind of an inner strength, because if you're reasonably confident on what you would want to do, then generally, yeah, one would be able to kind of come to a particular position where you can defend your position of why you're doing something. And then at this particular junction, then you're totally getting into this problem and you're trying to develop a slightly in-depth kind of interest in that. How did you now start getting into really slightly more broader perspective?
Yeah, that's so. I think at that stage, so when
Hmm.
I was working on this, sort of biophysics or biological physics was still a
Yeah,
very,
yeah.
very, theoretical biophysics, let us say,
Hmm. Hmm.
was very, very new field back then.
Absolutely,
Using
absolutely.
these kind of ideas for
Hmm.
biological problems was quite new.
Hmm.
And
Hmm.
so while I did enjoy this, I I did work on this, and my first publication was also on this topic. My
Okay,
first
okay.
research project and my first research paper.
Hmm.
And but I also in my finally I also did do again another project on conventional
Hmm.
condensed matter physics as well. And But when I was applying for my PhD programs,
Hmm.
I was
Hmm.
basically applying for physics departments where there is a
Bio.
good possibilities of somebody doing theoretical biology.
Very
So I was
interesting.
looking
Hmm.
clearly for departments
Hmm.
where it
Hmm.
was present. And of course, I don't know the current status of how people apply to physics departments. Back
Hmm.
then, you apply to a department, you don't apply to a faculty.
You're right. You're right. Yeah.
So,
Yeah.
so, and so as long as the department takes you, you then go and do courses and then find an advisor by the end of first or second year.
Yeah.
That was the sort of norm in most US universities back then. I don't know if it has, I think it is still the same if I'm like the physics departments by and
Hmm.
large maintain the same culture. I could be wrong, of course, about this.
Hmm. Hmm.
So there was no super sort of very, in some sense, that vagueness helped a bit.
Hmm.
It
Hmm.
might also
Hmm.
have turned against me entirely, but that vagueness helped in when I was applying. So I was more focused broadly on departments and the possibility of finding somebody. And usually, I would make sure there are at least 3-4 people who I could potentially work with, and
Hmm.
that even
Hmm.
included the options of conventional and condensed matter physics.
Hmm. Hmm.
Um, okay, so and that's how I sort of applied to various places, and among various places applied, I think I got offers from nowhere. Okay.
Huh. Okay.
But one funny thing had happened. I noticed that Ohio State University had no application fee. Okay, I thought,
Yes.
oh,
Yes.
then I'll apply. Okay,
Obviously.
and that was the only place where I actually got an offer.
Wow. Okay. Very interesting. Very interesting.
So, so that's how I ended up going to Ohio State University for my PhD.
Wonderful. Wonderful. And there at Ohio State University, you also probably, of course, you are making a transition. And again, there is
Yeah,
one more transition which is happening.
yeah, yeah,
And that transition is also sometimes even bigger transition, because you're really,
yeah,
going into totally new kind of
yeah.
country. How was that experience, that transition?
Yeah, transition from studying in India to
Yeah,
studying in
yeah.
US. Is that what you mean?
US. Yeah, yeah, yeah,
Yeah,
yeah.
yeah, yeah.
And also
I,
kind of going from more academic education viewpoint to a
mhm.
research ecosystem viewpoint. Yeah,
Yeah, absolutely. Yes, I think
yeah,
that's
yeah.
a interesting transition. In many
Mm,
many ways, the
mm,
academic part of it was really easy. So I felt
mm,
that the
mm,
coursework was incredibly easy. In the
mm,
PhD
mm.
coursework was incredibly easy in my grad school compared to what I had in my MSc, which was
MSc.
really important. Which was
uh,
really important because now, I could also focus a lot more on the concepts
Yes,
and the
yes.
sort of, the contexts and
Mm,
the philosophy of learning and doing research and solving problems.
mm,
Whereas
mm,
in the, I think maybe, I don't know how many other students have felt this. At least my feeling, is that it's probably, it may be even to today, large fraction of our, many, ICER IIT like curriculums, ICER
mm,
IISc
mm,
IIT like
mm.
courseworks in the undergrad. I think we will do a great favor to students if we reduce the coursework by 25 to 50%, the content,
Absolutely,
and let
absolutely.
students think a bit more
Mm, mm,
and,
mm.
figure out things on their own a bit more.
Absolutely,
Uh,
absolutely. No, because
Instead of putting
you're
them on a. Go ahead. Yeah.
yeah, yeah. No, I totally agree with you. For the main reason is that you don't have to also give all the information now, right? Because
Yeah.
earlier information was on premium, because
Mhm.
that was a single channel kind of percolation, so to speak. Now students have so many avenues to get whatever information is necessary, thanks
Yeah.
to internet. And then one has to redefine the role per se of how we are going to teach. And I agree, in fact I actually agree totally on this, that we should not be teaching too much to the students. And that is an important point what you're making. Yeah, yeah.
And I have tried to incorporate it in my own teaching. If anybody looks at the theoretical ecology course in a standard
Mm,
curriculum,
mm, mm,
I teach roughly just about half to 75%, depending on the student response.
mm, mm.
I know
Yeah,
sometimes it's half, sometimes it is up to 75 to 80%. It really depends on the composition. I
compulsory.
absolutely maintain no rigid sort of requirements of how much content to teach. Uh,
Absolutely.
okay, and because at the end of the day, I want as many to go back thinking, oh, that's something in the course. Then going back, oh, I finished one course. Oh my God, it's a relief.
Mm,
If you know, I would rather have that feeling among students that they learned something in this
mm.
course. In fact, I
Absolutely.
actually do get some comments from some students saying the content should be more, and I'm very happy about
Yes, yes, yes.
it.
In
Okay,
fact,
it means I'm
this is
doing a good
a
job.
absolutely. We'll come to the teaching part. We'll elaborate this aspect a little bit more, because that is an important topic. What you're really mentioning is something very critical. So, but in your own experience, the US experience, as you mentioned, it would have been relatively easy because you would have already undergone a very rigorous training in IIT Kanpur. And then, how was your experience? Because you are now working in physics department on problems which are already kind of entrenched into ecological issues. That is a fascinating thing because it's not a trivial thing. For listeners, I should mention that to first of all work on a problem such as ecological sciences requires a reasonably broad understanding of not only, for example, statistical mechanics, but also a slightly more deeper understanding of biology, right? And given that you would have been in a traditional physics department trained IIT Kanpur student with engineers all around you, how did you further really get that interest in really looking at this problem, Vishwesha?
Yeah, so I think so. First thing to note here is that I did not my PhD topic in the beginning was not about ecology at all.
Oh, is it
Uh,
okay?
yeah,
Interesting.
so there
Okay.
was one faculty was working on biological problems,
uh, uh,
something related to DNA, RNA folding.
mm, mm,
Okay, but that person didn't have funding. I would have had to be TA throughout.
mm,
Okay,
mm,
now and so I had mixed opinions about that.
mm,
So
mm,
another professor who works on more conventional condensed matter physics,
mm,
who I had also taught various condensed matter physics courses. Then I really liked his teaching and his approach,
mm,
and I had working on projects with him. So as
mm,
so so while working on course projects with him,
mm,
uh, Professor David Stroud is his name,
mm.
where on conventional condensed matter physics, I also ended up working on a research paper with him.
Wow.
Okay,
Okay. Okay.
okay. So, and I enjoyed working with him.
Mm.
And then that one paper became also two papers. Okay, so so I thought, okay, this is a topic I'm doing okay. It's not
Mm.
a topic that I sort of absolutely thrilled about in my life.
Mm.
Okay,
Mm.
but okay, things are going okay, and
Things are going okay. Yeah. Yeah.
yeah, and I had heard from several people that in a PhD it's extremely important to have a extraordinarily good and supportive
Mm.
advisor. That really is so
Absolutely.
important. Okay,
Yeah. Yeah.
and that checkbox was like fully on. So
Mm.
and I already have like one paper and another one is being done. This was the end of my first year where
Okay.
I now have to begin making decisions about who is my PhD advisor.
Mm. Mm.
Okay, and discuss with a few faculty and so on. And so I thought, okay, this is fine. No, I shouldn't complain too much. Okay,
Okay. Okay.
so I only had two or three choices, of which only he was willing to take students at that time.
Mm.
And although this would again mean that I would be a TA for the entire PhD duration, I also realized that I'm not too bad in teaching for the first time, and I
Yes.
also
Yes.
like teaching
Uh
both.
huh. Uh huh. Nice. Nice.
Okay, so I
Mm.
like teaching one, and I also found that I got incredibly good reviews in my teaching, which was
Mm.
extremely surprising.
Mm.
Okay, uh, so I thought, okay, I can manage teaching and I am also doing research. It's not affecting my research anyway, so it should be fine. By and large, it's okay.
Mm.
So this advisor is really nice and topic is okay. I'm
Mm.
getting
Mm.
papers, so I will finish PhD, and by the time I will find out more topics that I'm really interested in.
Mm.
So now towards the uh, and I had also worked on a project with the other person I mentioned about RNA and stuff. Okay, so now I'm somewhere towards the end of my second year now. So
Mm.
between these two faculty, I have three papers done. Okay, two
Okay.
published, I think, and one was about to be written up.
Uh huh.
Okay, now one email comes
Mm.
from a professor in the condensed matter group saying that he has
Mm.
an RA position and on a topic which is about understanding lake ecosystems from a non-linear dynamical systems perspective,
Nice.
non-equilibrium physics and
Mm.
non-equilibrium phase transitions perspective.
Mm.
Okay, it was like literally a very short email of two paragraphs about the project, and if any student is interested, come and talk to me because there is also a funding for this. And there
Mm.
was our grad sort of program convener had said that it's strongly recommended to go to a faculty who has funding because TA ship is being cut down, so that
Nice.
could turn out to be a problem
Mm.
later on.
Mm.
Although we will never really throw out any student, we are strongly encouraged to do that.
Mm.
Anyway, I mean, I said, it doesn't hurt if I just go and meet somebody telling I like the project you mentioned, tell me a bit more about it.
Yeah.
And
Yeah.
I
Yeah.
did that. I went and
Nice.
I
Nice.
spoke to him. I like the project, the description. I'm not going to join you because I already have finalized everything, but I just want to
Mm.
know a bit more to sort of understand what kind of problems are this, because I had done a
Mm.
course on nonlinear dynamics long back, and I had really enjoyed learning about things like bifurcations, diagrams, and also I had also done courses on equilibrium stat phys. I really had enjoyed doing those. And then I had a meeting with him, and then the first meeting, after the first meeting, I said I want to meet you again. So I had like two or
Nice.
three more meetings to discuss the project and so on and so forth. So at the end of these three meetings, I really felt that you know, the whole point of PhD is to do something that's really really interesting. I mean, the
Mm-hmm.
whole point
Mm.
of taking MSc over engineering was that I should be doing something very exciting instead of
Yes.
just going by trends. And the whole
Mm.
point of choosing for my master's thesis to work on ants instead of, let's say, string theory or gravitation is again because I should do what really interests me and what is going by trend and what is comfortable also, right?
Mm. Mm.
Likewise, if I were to apply the same principle here,
Mm.
okay, I'm doing okay. I'm, all are in general okay, but if I really think about what is really exciting from my research point of view,
Mm-hmm.
this is what I really I'm finding interesting. I also went back and dug up more papers, and
Mm.
that's when I'm actually reading that there is a field called ecology.
Ecology.
I
Wow.
always
Okay.
thought of it as biophysics or something
Uh,
like
uh.
biological physics maybe. These terms were more prevalent even
Mm.
now. I think
Mm.
in physics departments in
Yeah. Yeah.
across the world. So this is the first time I'm actually learning about a word in a formal sense,
Mm.
in a serious way. Maybe I'm sure, of course, I have heard about it. Not that I haven't
Mm.
heard, but I think maybe the word environmental sciences may have been
Mm.
more in my mind,
More exactly. Yeah.
okay,
Yeah.
rather than ecology. Okay,
Mm.
so I read about it and I went to various ecology departments, web pages in the US, what all kind of theoretical work they do,
Mm.
and that seemed extremely interesting to me.
Interesting.
Okay,
Mm.
and then I also at that point of time found out various web pages, and one web page, one of the professors in Princeton back then had put up his grant proposals also on the web page.
Mm-hmm.
And
Mm-hmm.
then I went through some of those, and that had flocking dynamics in
Mm.
the grant
Mm.
proposal, and about how do we apply ecological thinking to conservation,
Mm.
which I was always very very interested in, and theoretical ecology principles in applying for in applied ecological contexts,
Mm.
and all
Mm.
those really really interested me, both from a sort of my sort of other interest throughout my sort of teenage to young adult life was looking at forests and nature and so on, and this seemed like a really good intersection of my sort of natural interest in outside academics, as
Mm-hmm.
well
Mm.
as my academic interest of sort of what is now non-equilibrium physics and nonlinear
Mm.
dynamics
Mm.
sort
Mm.
of topics. And
Wonderful.
so this seemed like a really great intersection. Okay,
Wonderful. Wonderful.
so then after thinking about this for some time, I took the massive risk of changing the advisor. Okay,
Okay.
this was at the close to end of my second year. Okay,
Wow.
then
Okay.
so and that's when I started actually working on
Mm.
theoretical ecology.
Mm. Mm.
So basically looking at phase transition like phenomena
Mm. Mm.
in the
Mm.
context of ecological systems, and how can we use mathematical models to build predictive tools for ecological systems.
Echoes.
So that
Wow.
was the sort of final switch, tipping.
Switch.
And
Tipping.
interestingly, I was now studying tipping points.
Yeah.
Tipping points in ecology was what I would be studying, and
Yeah.
I
Yeah.
know that was sort of the career tipping that now I have continued in the trajectory since then.
Wonderful. Wonderful.
Yeah.
So, were you also attending meetings and conferences during that time? Because that is also dipping again into a new ocean, so to
Mhm.
speak, because you are
Yeah,
now probably getting exposed to new questions which are
yeah,
generally not
yeah.
discussed in physics. And
Yeah,
uh,
absolutely. So
mm,
luckily there was this. There is, I think now it was probably partially closed or something like that. There's
mm,
institute called NSF funded institute called Mathematical Biosciences in
mm,
Ohio
mm,
State University.
mm, mm,
So it was an
mm,
applied math initiative called Mathematical Bioscience (MBI), Mathematical Biosciences Institute.
mm,
In that
mm.
year, where I switched my fields,
Ah, mm,
to work on with a new PhD advisor, Professor Jayaprakash, on
mm.
this topic of theoretical ecology. They had this thematic year on theoretical ecology, a
Ah, okay.
series of workshops. Once every 1 or 2 months, there was a
Mm,
very very good workshop. Where a lot of ecologists from all over the world would come and attend and
mm,
present their work, including many student presentations. So I attended many of them just by walking in many of those talks and workshops.
wonderful.
And that
Wonderful.
also gave me sort of, a very easy introduction to
Mm,
sort
mm,
of the entire broader field of ecology. How do people not only do modeling, they are
mm,
actually also very, very serious about making sense of these models in light of data and
mm,
building
mm,
models in light of data. Although I never really could figure out in my PhD time, to be very
mm,
honest,
mm,
how do we really integrate them really well?
mm,
I was really sort of got slow exposure to that that way of thinking as well. How do we sort of
mm,
seriously integrate? My PhD thesis was mostly on the theory side and partially towards the end on how you can in principle use data to measure these things. That
mm,
was the
mm,
closest
mm.
I came to in my PhD thesis.
Wonderful.
Uh,
Wonderful.
uh, so that was sort of exposure to the more formal field now,
Mm, mm.
and that was really really good. And I was
Wonderful.
extremely lucky
Wonderful.
that to have had that amazing coincidence of those workshops happening exactly at the right time for
At
me.
the right time for you. Yeah.
Mhm.
This is truly kind of remarkable because this also tells you that the training which you got as a physics student was very useful, right? Because
Mhm.
that is one of the strengths of an education in physics, the ability to really, kind of branch into any field. Of course, there is a lot of application of mind which has
Mhm.
which has its own requirement, but that strong foundation of taking up problems and looking at it from a quantitative viewpoint is one of the strengths of physics education, so to speak. And it's very nice to hear that aspect here, very nicely. So now you're taking the game to a bigger arena, so to speak. You are now finishing your PhD, and again another transition. Like,
Mhm.
always it happens in academics. Until you really settle down in a permanent position, you're always making a transition almost every half a decade or so. How was
Yeah.
that transition into a postdoc? And you also went to Princeton, which
Mhm.
probably would have also kind of opened you to new avenues also. Tell us a little bit more, Vishwesha, about that.
Yeah, sure. Um, so I think that that transition was not as difficult as I had anticipated.
Mm, mm.
So I applied for various postdoctoral position. Now I was now applying to ecology departments.
Yeah, yeah.
I was now directly applying to people who are doing theoretical ecology
Mm,
in
mm,
ecology departments.
mm,
Okay.
mm,
So this was not physicists doing theoretical
mm, mm,
ecology or theoretical biology in a physics department. So that was one big change that I did at that point of time. And my PhD advisor, Prakash, he
mm,
was extremely clear about how to do good science, and I really learned
mm,
massively in that
mm,
process. I think the
mm,
uh, not only I mean, my sort of my sort of biggest sort of learning from him was not only the papers that I wrote with him,
mm,
but how
mm.
do we actually do science? How do we
Science. Yeah.
actually
Mm,
try to do impactful science?
mm, mm,
He is of course a brilliant scientist and brilliant
mm,
physicist, very very well
mm,
known
mm,
in the community of non-equilibrium statistical mechanics
mm,
and broadly
mm,
physics. To me, the sort of take home message from PhD was how do we really do good science? It should
mm,
not be he is a formally trained theoretician,
mm,
and
mm,
he could have sort of trained me to do just theory. Okay,
mm, mm, mm,
but although that was by and large what I did, but
mm,
what I took away from it was, how do you also make sure your theory is something that an empirical person will
mm,
sit and take note. He said that unless one makes that effort,
mm,
you
mm,
know, you're probably not going to make huge contributions.
mm,
Okay.
mm,
Okay, maybe that was possible at some era in some, if you had the luckiest coincidence of starting in the beginning of a new field where you
mm,
could do theory for the sake of theory.
mm,
A new field is emerging, and the first theory paper you wrote is has sufficient novelties and interesting insights.
mm,
So therefore, everybody will cite it and like it, irrespective of whether it was useful in an empirical sense or not. But
mm,
in the
mm,
longer term, his argument was that how do we should always make sure that we develop theories
mm.
keeping real context in mind in
Mine.
science,
Okay.
and that's
Mm.
really where you will make the biggest impact. In fact, both in theory as well as in in empirical world.
Absolutely.
And
Absolutely correct.
and that was my
Wonderful.
biggest sort of take home. And
Mm,
given that
mm,
context, I now wanted to work with people who do both theory and data, who can sort of
mm,
integrate theory with data.
mm,
Although
mm,
my role would still be probably on the theory side,
mm,
because
mm.
that is my strength, right?
Zen.
That would
Yes.
have been. So that's the kind of positions I applied to. And then,
Wonderful.
and interestingly, and I mentioned to you when I was making the switch within my PhD, I
Mm,
had
mm,
found this professor who had put this, proposal on flocking,
mm.
right?
Yeah. Yeah.
So, in some sense, that sort of circle goes back there.
Circle
Okay,
goes back there.
so
Exactly. Yeah. Yeah.
so
Yeah.
his
That's.
his postdoc then,
Ah.
it was actually Simon Levin's grant proposal was the one I am referring to,
Uh huh.
and Ian Couzin was his postdoc back then, at which time this proposal was written. Now Ian Couzin
Wow.
now joins Princeton as a faculty member,
Faculty.
and then
Wow.
and I am his first postdoc. I know in Princeton to work on collective behavior. So
what what
so
a kind of a, as you say, kind of circling back on this totally, right, in that sense.
yeah.
Wow.
So that was my sort of now working on ecological problems, theoretical
Mm,
ecology problems, being in the ecology department, and I
mm,
was and apart from my own research work back then, again
mm,
to me now the thing that I found really remarkable and difficult at that point of time, of course it is still true,
mm,
is that how is it that some people
mm,
are able to do really good integration of theory and data. When we were meeting
mm,
here and there beyond our own project work, when we would meet other postdocs, other students, I was always amazed. Oh, how could this guy say, look at this data,
mm, mm.
and then make an amazing connection with the theory and say, let us measure this. I thought,
Nice.
oh gosh, I just don't have that skill.
Uh-huh,
How is
uh-huh.
it this guy could just look at this, video of animal moving and could make some connection to random walks, which
Mm,
why would, because I knew the theory of random walks,
mm,
but this guy was able to make this connection to this theory and let us make these computations to test the classic predictions. But I was always puzzled, why was I not able to do that?
nice, nice.
And I was trying to really work hard to learn those kind of sort of thinking, when
Mm, mm,
taking real data sets and sort of trying to make some measurements, some computations that again still made sense from a interest, from a theoretical point of view. Of course, there are a lot of empirical people who will, of course, a lot of analyze the data, but there is not always a strong theory that links them,
mm, mm.
right? But I know this
Absolutely.
connection of linking a what seems like a pure theoretical construct to real data. I think that was the
Data.
connection that I have, that was really intrigued me, and I was always amused. How are these guys able to do this?
Absolutely. Absolutely.
And that I'm finding it so hard. Okay.
Wonderful.
And that has been
Wonderful.
my interest, and that's what I have been trying to learn and do over the last decade as well, after joining as a faculty.
Wonderful, wonderful. So, which means also that you are now trying to, synthesize kind of theories which can now explain something which is happening in the natural world.
Mhm.
And natural world is noisy. Natural world is complex,
Yeah.
and whereas the mathematical world is precise, and of course there is a mathematical machinery to address these problems. So how was your kind of parallel kind of education in this, Shrisha? Because the education doesn't stop at master's level or even PhD level,
Yeah.
because as you
Yeah.
progress and learn new things, you will have to keep abreast with new developments, and maybe revisit old concepts and other things. So how was your experience in developing this expertise, because you'll always have to keep updating yourself, and
Yeah,
yeah.
absolutely. Yeah,
Mm,
yeah. So I mean, I think this it's a I think in this position it's a never-ending sort of learning curve, right? So
absolutely, yeah.
we have to learn new questions. What are the important new questions to address,
Mm,
and how do we address them? So
absolutely.
that's a never-ending learning process.
Mm,
So we learn by reading papers, talking to colleagues, talking to
mm.
students, and these days more so by talking to our own students, because I'm
Yes.
unfortunately now at a stage our time is gets diffused
Yes.
into so many different branches, right? So the most of the learning is because students learn something and they teach you.
Mm, mm.
So yeah, so that's the way it's been continuing.
Very nice. Very nice. So, before we really move into your current research interest, let's talk about the final transition
Mhm,
of transition from postdoc
mhm,
into a faculty position, which is
mhm.
generally a probably one of the is slightly, what should I say, first order phase transition, because there is already there is also a state change, so to speak, because
Yeah,
you are
yeah.
now going into a totally new responsibility altogether. So first and the foremost thing is, what motivated you to come back to India,
Mhm.
and second point is, how was your transition? What was your experience uh, during that?
Yeah. So So I think I was so it was very very clear to me from the day I joined PhD that I want to come back to India
Mm,
for the fact for any career position I choose, and I
mm,
had
mm,
sort of thought of two potential career
mm,
paths. One would be a faculty position, academic career
mm,
path,
mm,
uh, and second was an industry position, which
mm,
would be
mm,
more on the lines of again where it could be probably mathematical modeling or data
Model.
analysis,
Yeah, yeah,
wherever those
yeah,
skills can be used, right?
yeah, yeah. Understood.
Um,
Yeah.
so those were the two career paths I had in my
Mm,
mind, and so by the sort of 1.5 to 2 years through my postdoc, when I had my
mm,
first publication, around the time
mm,
I was going to have a first publication,
mm,
so I had started to apply
mm, mm,
for various faculty positions in India, and I applied for I think a dozen places maybe.
mm,
Now the
mm.
challenge here was that I'm this hybrid guy, right?
Yes, yes.
Interdisciplinary
That's
guy. Where do you fit? Is
yes,
not
yes.
clear,
Yeah.
right? So the advice that I got was that you apply to any department that you would like to be in, and
Mm,
as
mm,
widely as possible, because you just
mm.
don't know what others are thinking.
Yeah,
The
yeah.
worst case is a rejection, which is anyway very common. So
That's true.
so don't worry too much. So
Mm,
basically, in a given institute, for example, IISc or IISer or any
mm,
place, I would send applications to both the physics and the biology,
mm,
and I would tell them that I have applied both. You
mm,
decide
mm,
what is more suitable. So that's the strategy I took, and I think I applied to around 12 places, 10 to
mm,
12
mm,
places in the first round of applications that I
mm,
did, and then when I was visiting India during
mm,
one of my break times, and I also gave talks in about half a dozen of
mm,
these places, 6 to 8 places,
mm,
uh, and uh, and luckily within about 6 to 9 months of my applications, I had like some offers, and I decided to join ISc among
wonderful,
those.
wonderful, wonderful.
So yeah, and it was towards the end of my third year of my postdoc.
Postdoc. So it
So
all
it
kind of
was
worked out
perfectly aligned
perfectly.
aligned with time. Yeah.
Excellent, excellent.
So that was sort of it wasn't as I think the situation now is incredibly more challenging with the number of
Mm,
positions and the number of and the expectations have go both sort of
yeah,
skyrocketed, right? So
absolutely.
luckily I was a decade ahead of that. I was born one
Yeah.
one decade earlier than that.
Exactly, exactly.
uh,
No, because I had similar experience because people who were kind of coming back roughly around 2010s and all,
mhm,
I can see because now things have become very competitive and also extraordinarily specific in terms of
mhm.
the expertise what they are seeking,
Exactly,
and
exactly. Yeah.
yeah, it's kind of a tough situation. I kind of sympathize with a lot of people
Mm-hmm.
who are really looking for academic jobs.
Mm-hmm.
But a good thing is the industry jobs have also come up reasonably good in number, which was
Yeah.
not the case when probably we were also looking for.
Exactly.
And
Yeah.
yeah, and for sure salaries are very different. There in industry, you probably you would make what you would do in 1 year in academia, you would get it in a month almost, so to speak. Yeah, very nice, very nice. So this actually gave us a very fantastic kind of overview of your biographical aspect of it. Now we're going to switch to your current research interest, especially your questions of interest to you and your research group. Briefly tell us a little bit about your own research interest, Vishwesha, what you're working on, and what is your laboratory interest now, what kind of methods you people are working on. And, yeah.
Mhm. Yeah. So right now we are interested in two broad themes. Okay. So one theme is about understanding really large scale ecosystems.
Mhm,
Okay.
mhm,
For example, you can think of forest ecosystems, or you can think of lake ecosystems. You can think of savanna ecosystems.
mhm,
Okay,
mhm,
where there is mostly grasses and a few trees. Okay. Now, one thing that very interesting that comes out if you study large scale ecosystems is
mhm,
that you can think of them as like phases of matter.
Mm-hmm.
Okay.
Mm-hmm.
So what do I mean by phase of matter? Everybody knows what's a liquid, what's a solid, and what's frozen state. No? So liquid, solid, gas. Everybody knows these phases, right? And we know
Absolutely.
that by changing usually one parameter like temperature, we can go from
Mm.
one phase to another phase. Okay. So likewise, and each phase has some characteristic properties.
Properties, yes.
Each phase has some very characteristic properties.
Mm.
And when we cross some threshold values, we call them critical points in physics. Okay.
Mm.
No, you go to a new phase, which has again some characteristic properties.
Mm.
Liquids all have some similarities compared to the solid phase. And likewise, the gases are very different from liquid, and gases have a characteristic property. Now, the idea is that the similar thinking
Mm.
can also be used when we think of ecosystems.
Mm.
Okay. For example, if we can think of forests, where you see lots of trees, nearly full canopy, and that is
Mm.
one
Mm.
state of an ecosystem, of a vegetation ecosystem. On the other
Mm.
hand, savanna ecosystems, which have predominantly grasses and very few trees, that's
Mm.
another phase of an ecosystem.
Interesting.
Okay.
Mm.
Okay. So in fact, the very interesting idea is that by we can tune temperature of a
Mm.
material and change properties such as liquid to solid or liquid to gas phase.
Mm. Mm.
By
Mm.
changing some parameters in the
Mm.
environment, okay, we can go from one of these vegetation phases to another of the vegetation phases.
Nice.
Okay,
Nice.
and these were all some ideas that people had for a long time. Okay, and over the last 2 decades also, even have empirical evidence that this could be actually true.
Mm.
Okay,
Mm.
for example, if you think of again the vegetation ecosystems I was mentioning,
Mm.
so rainfall seems to be the key driver that determines the vegetation state.
Vegetation.
Okay,
Okay.
so at the lower end of rainfalls, you will predominantly find savanna ecosystems. Okay, savanna ecosystems with a very small number of trees. Okay.
Mm.
On the
Mm.
other hand, at the higher end of the rainfall region, you will
Mm.
find forests, including even or the extreme rainforests. Okay. So if you plot the tree cover,
Mm.
so in physics, what we'll do, we plot some variable as a function of the driver, right? We call them order parameter in physics. Okay,
Yes. Yes.
here, the equivalent could be something like what proportion of the landscape has, let's say, trees.
Mm.
If you
Mm.
look at that graph as a function of rainfall, you see that it undergoes a similar type of transition
Mm. Mm.
from savanna ecosystems, which have lower amount of tree cover, to forest ecosystems, which have higher amount of tree cover.
Mm.
Okay,
Mm.
so which sort of gives evidence that we can actually indeed think of ecosystems as different phases of different phases, just like in
Mm.
physics. Okay,
Nice.
so
Nice.
what we work on in our lab is not given that there is a very good mathematical machinery that can explain phase transition in physics. Can we apply similar mathematical frameworks uh, in the context of ecosystems?
Ecosystem.
Can
Very nice.
we uh, have a mathematical model that actually explains these transitions between different types of vegetation states as a function of some drivers like rainfall, temperature, and other factors?
Mm.
And if so, what is ultimately we want to understand the biological processes here, right?
Mm. Yes. Yes.
So it is not merely we have a model that produces features that look like what's in real data. We also want to understand processes. What are the biological processes
Mm.
that are actually affecting the phases of these ecosystems that maintain these ecosystems? And we want to understand in the context of ecology questions like what are the ecosystems in a stable state,
Mm. Mm.
or are they very weak? Are they, we call them resilience? Are
Mm. Mm.
ecosystems resilient to perturbations? Because there are always perturbations to ecosystems. Many of them are natural, some of them are also human induced, right? Now, if we can identify which ecosystems are resilient,
Mm.
and
Mm-hmm.
which are not, we can sort of take appropriate also management actions. Okay. So can we again use mathematical sort of frameworks to sort of come up with measures that can tell us how resilient are ecosystems?
Mm-hmm.
Okay.
Mm-hmm.
Uh, so those are the questions we are really interested in. How can we quantify resilience of ecosystems? Okay, using combination of ideas from mathematical theories as well as real data.
Real data.
you know
Nice. Nice.
and if you can quantify something like ecosystem resilience, and then
Mm-hmm.
we can identify different ecosystems along gradients of this resilience, and then we
Mm-hmm.
can focus on those that are less resilient,
Mm-hmm.
that
Mm-hmm.
are more prone to damages. Okay, so
Wonderful.
that's the
Wonderful.
broad sort of applied sort of angle to the basic research that we are also interested in.
Wonderful. Wonderful.
So
This also covers kind of a lot of ground in terms of the scale of the problem, because these questions probably can also be asked in various different systems, right? That is one of the strengths of such kind of natural systems. It can be applied to a school of fish, like
yeah,
what you worked on, very beautiful work, to all the way to even large ecological systems, where one is
absolutely.
looking at the geological or in sometimes even astrophysical situations. Of course, there the life process is still something which has to be explored in detail.
Yeah.
So in terms of your own research group, so you are mainly geared towards asking these questions and addressing them from a theoretical viewpoint and a modeling viewpoint, and you're also involved in setting up experiments.
So for this question in the context of ecosystems,
Mm,
so we do theory, we do
mm,
computer simulations, and we try to come up with predict measures. For example, we want to tell, if you had data, you would go, please go
mm,
and measure this. Okay,
mm,
that's
mm,
our goal.
mm.
So the
Yeah.
entire theoretical
Yeah.
framework is sort of geared towards this goal of, okay, can I tell an empirical person, please go measure this quantity?
Mm,
If this
mm,
quantity looks like this, then this is what you can infer. You can
mm,
infer
mm,
that the resilience is low or high. If you
mm.
found this kind of patterns, then you should infer this. That's the
Okay.
broad goal that we are
Broad
interested
broad goal.
in. Okay, but we for this case we don't do experiments. We
Mm,
actually collect data that satellites collect for us.
mm, mm. Nice. Nice.
So satellites collect a lot of vegetation data.
Absolutely. Absolutely.
Okay, so we are actually using satellite-derived ecosystem data
Ecosystems.
sets.
Wonderful.
Uh,
Wonderful.
so in fact, right now, we are, for example, just to give an example of recent work that we have done,
Mm,
we wanted to ask whether what kind of phases that forests that we find in northeastern India exhibit.
mm,
Okay,
mm.
so so we sort of took satellite derived vegetation data,
Nice.
and we sort of argued that they are not. So if you go back to physics, if
Mm,
we recollect what we learn in phase transitions,
mm, mm.
even for somebody who doesn't know, we can explain this very easily, I think, which is there are two types of phase transitions, right? One where
Yeah.
things dramatically change, discontinuous or first order phase transitions, and then there are continuous phase transitions, right? Where
Yes. Yes.
things change gradually when you change the
Yeah,
driver.
absolutely. Absolutely.
So whenever there is a discontinuous change, it's a bit of a problem in ecological context,
Mm, mm,
because
mm.
for small changes in the driver system can dramatically change from one state to another state, right? So
Absolutely
we
right.
want to often know whether a given ecosystem belongs to the discontinuous category or a continuous category,
Continuous category.
right?
Yes. Yes.
Okay,
Yes.
so what we found in the context of northeastern forests is that they are more of a continuous
Mm.
category, continuously changing vegetation type rather than a discontinuous changes. Of course,
Interesting.
if you look at the landscape level, if you look at very
Mm.
micro scales, it could still be discontinuous, could be there. But at the very large scale, if you look at the vegetation cover, that seems to follow a continuous pattern rather than a discontinuous pattern. That's an example of
Wonderful.
where we have a theoretical framework to think about these problems,
Mm.
and then we tell if you measure and if you plot this graph, we can infer this, and we use those ideas to real data sets. So, in the context of studying ecosystems, we use basically satellite derived data sets.
Mm. Mm. Wonderful, wonderful. So it also means that there are so many interesting kind of avenues to apply this thinking, right? That is something which is it makes your life more enjoyable in terms of doing research, because one of the issues, if you look at traditional physics problems, there is a kind of now kind of specific, uh, what should I say? There is some kind of framework within which you have to do the thinking. In these kind of questions, you can really be more divergent and apply to various different problems and other things.
Yeah, absolutely. And you made a
Yeah.
very interesting point
Mm,
about being able to apply this to very different
mm,
types of data sets. No, let me give you
mm, mm, mm,
some very interesting sort of stories about this. So
mm, mm.
this is a topic that I have been working on since my PhD days. Okay,
Nice, nice.
how
Okay.
can we apply these ideas of phases and phase transitions from physics to
Mm,
ecological contexts? Okay, so one of the problems that I worked on towards the second half of my PhD was,
mm,
for example, can you measure some quantities if from real biological data sets
mm,
that can tell you whether a system is approaching a disastrous tipping point?
mm, mm,
Okay, so it has not happened yet,
mm,
but
mm,
can you analyze some data sets that I give you
mm,
to sort of anticipate any potential a tipping event? That was
mm,
the basic
mm.
idea. We proposed some measures for it, and we were not the only one. There were a couple of other papers. We were left
Nice,
4 or 5
nice.
papers in that window of 2005 to 8, where there were several metrics that various theory groups
Mm,
proposed. Okay, now the first empirical study, and we
mm,
all had lakes, and I had lakes and forests in my mind, and I was thinking in my mind always, I know this is
mm,
an interesting theoretical idea, but how will you ever measure something like this in real data? That was my worry.
mm.
Although we pitched hard in our paper saying, at least it is in principle measurable and so on and so forth.
Mm,
Okay, but I had my own doubts.
mm,
But
mm.
in 2010, there was a paper published that actually put these ideas to test.
Okay.
Okay. Now, can you take a guess on how did they test this? What system, what ecosystem did they test?
Birds, just
No,
guessing. No.
no. It has to be
Um,
ecosystem, not just a
Echoes.
species.
So not a species. Okay, okay. So maybe some kind of a uh, forest land somewhere in let's say northeast region. No.
No, no, no. So interesting guesses, no doubt. Okay.
Uh,
Uh, the sort of they studied an ecosystem of Daphnia. So Daphnia
oh,
are the small organisms that swim in lakes. So what they
wow.
did was a they had a beaker where they had Daphnia that they were growing in beakers. Okay, so it's like a miniature ecosystem.
Because it's okay, okay.
Okay,
Mm,
so what they did was they actually subjected in an experimental setup in a laboratory room,
mm, mm.
subjected these populations to collapse.
Okay, okay.
So in a very controlled experimental way, they made these populations collapse as a function of time. And then they said before the collapse happened, if I had gone and measured all these metrics these theoreticians were
Mm.
telling, would I would they have found those signals that we
Ah,
predicted would
okay.
happen? Okay, and that's how they actually tested. They actually found that to be true.
Wow.
And what is really interesting is that the scale that at least I, as a naive
Mm,
PhD student back then, had was a scale of ecosystems,
mm,
right? But the
mm.
scale that they studied, scale of ecosystems, as you rightly pointed out, often is huge. But
Yes,
whereas
yes.
they studied in a small, few centimeter square area,
Mm.
populations in those small areas. But the concept is same. But the same concept can be applied across scales,
Very
from
interesting.
extremely small scales to large,
Mm.
very 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 large scales. And in fact, when I was doing my PhD, I hadn't even heard of the name Daphnia.
Ah,
Being
ah.
from physics background, I wouldn't even know that something like a bad Daphnia would even
Mm,
exist.
mm.
Okay. But that I think is in some sense the beauty of theory. It
Theory.
sort of tries to sort of find common universal phenomena
Mm,
that sort of spans scales, that sort of spans organisms, more than what a theorist can think, right?
Think. Absolutely, absolutely.
uh,
Wonderful, wonderful. This is something which is very, very interesting. And also, to a large extent, it means that you will also be attracting students from various different backgrounds, right? That is
yes.
another important aspect. So, just briefly tell us about your group. How big is your group, and what is the kind of general distribution in that?
So right now, so we have a really good mix of students from all backgrounds. It has always been
Nice.
the case in our lab,
Mm,
going by the nature of the work that we do. For
mm, mm,
example, right now among PhD students, there is one from computer science,
mm.
there is one from physics, there are I think two from traditional biology backgrounds.
Mm, mm,
So, and among the postdocs, one from traditional ecology training,
mm.
one from physics, theoretical
Mm.
physics training. Okay,
Nice,
undergrads,
nice.
again, very similar distribution.
Sure. Mm,
Math,
mm,
I have some math
mm,
undergrads, some physics undergrads, some biology undergrads.
mm.
So yeah, so it's always a really interesting mix of all these physics, math, uh, computer science, and biology backgrounds.
Wonderful,
So we
wonderful.
have students from all these backgrounds.
So, if there are students who are listening to this, please see that you would be able to work on problems of such interesting kind of variety with some particular anchored discipline, right? That is an extraordinary aspect of working in ecology and kind of environmental aspect of science too. So we'll broaden the prospect a little bit more, Vishwesha, in
Hmm.
terms of you kind of exploring your thoughts on science and society interface per se.
Hmm.
Uh, First and the foremost is that you also are somebody who has gained a lot of uh, uh, applause in terms of teaching, which was also reinforced recently by by IISc, kind of honoring you as a very good teacher. So, what do you think is the role of teaching per se in the way it actually can influence? As you can see in your own career trajectory, it has played a critical role. Could you also tell a little bit about what are the prospects of teaching and learning per se in an academic environment? How should it go about, or what kind of newness should be brought into the picture? Because as we discussed earlier, there's already a transition which has already happened.
Yeah,
uh, it's not only driven by information. So if you can
yeah,
let us know your thoughts, that would be very nice.
yeah. I think it's. I think the last point you made, I think you made in an earlier conversation
Mm,
also.
mm.
Information is now
Yeah,
relatively much more accessible, right?
absolutely,
But what
absolutely.
students may not have access to is how to process the information,
Mm, mm.
right? uh,
Absolutely.
and uh, and among all possible informations available, you have to
Mm,
filter and choose the most interesting, most
mm.
insightful. I think that's where the role of teachers really is.
Yeah,
It's not just sort of add more and more breadth. I think uh, uh, I think adding extraordinary breadth and only dilutes the insights that students can gain in a classroom setting
absolutely.
from any of them. I think if we can still somehow maintain the topic breadth,
Mm.
but reduce the content,
Content, yes, yes.
but increase the depth. I
Mm,
think that's where we can certainly. I think we can, as teachers, we can play a really, really important role. I think for each discipline, if we were to take, we can ask, "Oh, do I really need to teach this? Do I really need
mm,
to teach this?"
mm.
At the end of the course, what is that the student would want to be sort of really be appreciative of this field? In a 1 semester long course, which is
Mm,
reasonable. And then somehow, I mean, see the thing that really has always worked for me. I think
mm,
this probably works even if you are not a great teacher. See, there are some
mm,
extraordinary teachers,
mm,
and I've had some extraordinary teachers in my undergrad schools everywhere, and those
mm,
are so few.
mm,
Okay, and somehow there is an expectation that a good teacher has to be of that type who has really good oral communication skills,
Skills. Yes.
someone who seems to captivate the
Mm,
audience. I think that's the sort of sense of good teaching we often always have, right? I think that's extremely misleading and maybe not a very useful
mm,
criterion to either judge a teacher or to have expectation of those teachers
mm,
across the
mm,
board. I think for the very reason only few people can actually master those oratory skills
mm.
and to keep the audience engaged in very interesting ways. But I think what
Absolutely.
almost one I think most people should be able to do is to find methods of engaging students in the classroom. I think that with effort almost
Mm,
every one of us can learn. Okay, I mean just to give you my own example, if in a high school in my high
mm,
school,
mhm,
no, if you were to naively sort of say that the best students who were most articulate back
mm,
then will be obviously better teachers. I
mm.
think will be absolutely. If you were to use the criteria, I would be nowhere in the picture. For example, okay, I would have struggled to say a single sentence
Mm,
in a
yes.
coherent way.
Yes.
Okay,
Yes.
and uh, because teaching also requires extraordinary preparations about a topic.
Preparation. Yeah.
Okay,
Absolutely.
teaching is not just about speaking; it is
Mm,
about conveying the learning to somebody else, right?
absolutely.
And I think all of
Absolutely.
those can be done with I think in my the one method that I often try to follow
Mm,
is the following: is that can the students discover this on their own?
mm, mm,
Okay, what would it take for a student to appreciate this concept? Okay. Usually, students have a sense of self-discovery.
mm,
I mean, why
mm.
do we like our research project, even if it's probably of least consequence to the humanity, right? Because we discovered it,
Absolutely.
right? So,
Absolutely right.
likewise,
Absolutely.
isn't a student more likely to like, let's say, Newton's law if the student had a sense of discovery of Newton's laws?
Mm, mm,
Can we
mm.
not change our teaching methods in that direction instead of going and writing on the board?
Yeah. Yeah.
That's one extreme. The other extreme being an extraordinarily good teacher who just in a 30-minute period really
Mm,
convinces you to have to be writing. Yeah, there are two, even I think the much better than a great teacher convincing students about a concept is a teacher actually letting students discover the concept on their
come on, son.
own. Okay. Now, to the extent possible, I think if we can sort of use our teaching time in that direction, I think that would be really, really the right way because, as you said, information is there everywhere. But how do we process
Absolutely.
the information? How do we understand the information? I think that skill is certainly is not necessarily there, right? I think
Absolutely.
if we can
Absolutely.
turn classrooms to zones of self-discovering concepts of that topic,
Mm,
I
mm.
think we would have done a really good job in teaching, in my opinion.
Very nice. Very nice. One of the things which you mentioned in the passing during this kind of discussion is that there is also communicating what you have learned. In fact, one of the extraordinary uh, powers of teaching is that you learn. In fact, it is sometimes not kind of utilized as a tool to learn, right? Because the moment you externalize your teaching, externalize your learning in the form of teaching, the way you learn becomes very interesting and very different, right? Because the fact
Mhm.
that you have to really communicate what you have learned to somebody else has a kind of a very different kind of viewpoint. And my own experience has been similar thing because the moment you try to convey this in your class, the way you are preparing to understand that particular topic happens to be slightly different from, let's
Yeah,
say, if you're trying
absolutely.
to just grasp this only for your own understanding.
Mhm.
Partly the reason why I do podcasting is this because it also gives you an avenue to really communicate what you have learned in a slightly different format. And this ability to teach has to somehow be inculcated in even at a very early age. For example, even among school children, you would have observed, because
Yeah.
I'll come to that point, that you are also father to two beautiful twins. And that is something which children do very effectively, right? Because most of the time children have this very interesting ability to also communicate what they have learned, and you see that communication really leads them to understand things much better. And it's not just only formal teaching. It probably happens at all different levels. So have you thought about this aspect, Vishwesha? Because I'm very sure in the process of you teaching to students, you would have learnt a lot doing that. And
I think that can
sometimes
only be underemphasized and understated, right? How much we
absolutely,
learn when we teach a topic, right?
absolutely, absolutely.
I remember, see, I had no formal training in ecology or
Mm,
even
mm,
political ecology, right?
mm,
So,
mm,
uh, so when I first began to now teach theoretical ecology, and this, at least in the first 2 years, predominantly the classroom was PhD students in ecology. I had to, I'm teaching about ecology, which I don't know. I'm teaching about
okay,
using mathematical skills that they don't know very well.
they don't know well.
So I had this.
Fantastic.
So I had to basically learn ecology myself, right?
Yeah,
And then I
yes,
have to tell them that
communicate.
ecology is can be understood very well if you now use mathematics in it.
Matters,
So I
yes.
had this extraordinarily funny challenge, and in the
Mm,
process, I realized that although I could write equations,
mm,
I had I had I had not thought about infinite number of questions that students were asking.
mm,
It was
mm.
only when I sort of began to think about the questions they were asking, I understood what were the true underlying
Underlying.
assumptions, for examples in all those topics that I was teaching. All the
Nice.
mathematical models that we sort of had taken for granted. Okay. So, and also, why is that model? Oh, now I understand why this model is really nice.
Mm, mm.
Because now I understand the ecology of it really, really much better than
Exactly.
a typical sort of, understanding only from a mathematical point of view.
Mathematical. Yeah, yeah.
That was the way I had mostly learned, even when I had learned these things,
Mm,
right? I think that, in fact, I learned all of my, I may have known nonlinear dynamics, but
mm.
my theoretical ecology learning actually happened only because of my teaching.
Wonderful.
It was
Wonderful.
entirely because of my own teaching, and and I realize, which is why I sort of try to keep engaging with different topics every time, one or
Mm.
two new topics, just because I can learn better about them
Better about. Yes.
when I
Yes.
teach.
Yes.
And I
Absolutely.
think there is hardly any better method than teaching to learn a new topic. Absolutely,
Absolutely.
that
Absolutely. Yeah.
communication is
Mm, mm,
incredible. And again, I think, again, if we have to go back to sort of how do we teach better, making students also communicate their learning is
mm,
one way to ensure that they learn better. And again, if I go back to my own college times, the courses where there were presentations, I
mm,
used to hate them. The courses where I had to present something were also the ones where I actually really understood. And I
mm,
even still
mm.
remember what I learned.
Absolutely right. Absolutely. In fact, this is incredibly kind of effective, because even if when you prepare for a talk or even small presentation, and even if I have to make a small video or an audio recording, there is no way you would be able to do it without internalizing some very important aspects of it. And as I mentioned, this is something which is also very prevalent among children. A lot of things they do also has some very interesting connotation. And the peer learning, which is also something which has been talked about in education circles, is something which is very, very fascinating. uh, so Vishwesha, I want to also kind of touch upon other element of doing science, kind of embedded in a society. And in this particular case, closer to your own home, you're also father to two children. How has it actually influenced you in doing science? Because this is something which should be normalized, in my opinion, where one should especially talk more about parenthood, especially from a male viewpoint, especially from a
Mhm.
man being a scientist and also being a person who will take care of their children. This is something which has not been extensively discussed. And I know that you're kind of very dedicated father and you do spend quite a lot of time with your daughters. This is something which I would want to emphasize and give a little bit more time for you to express your opinion, and that should be normalized, in my opinion. Could you
Yeah,
please
yeah. I
talk a
think
little bit more?
it's really
Yeah,
important. I think
yeah.
so. I often, I'm I think it's really important
Mm,
that we talk about this topic, as you rightly
mm,
said. And then some of the ways I try to sort of uh, manage my sort of my science life
mm.
with parenthood is that to the extent possible, I don't take any work assignment that's beyond working hours.
Good. Very
Okay,
nice. Very nice.
okay. Usually, whatever the working hours that I define, by
Mm,
and large,
mm,
which is a regular in 9 to 5, sort of 5 to 5.
mm,
In fact, on most days I am home by 5,
mm,
because by the
mm,
time kids come, I should be home,
mm, mm,
and also on weekends.
mm,
I
mm,
really try to avoid. It's not that I never work on weekends. Of course, I work
mm.
on weekends, but I don't want it to be scheduled.
Scheduled. I get your point.
So
Yes.
because the moment it gets scheduled, I know, which also means that if some important thing comes up, I just don't have time for the family,
Time
right?
to exactly,
So
exactly.
I always, so the two things that I really make sure, to the extent possible. I mean, of course, there are always going to be instances.
Mm.
I try to avoid work commitments beyond office hours,
Officers. Very
scheduled
good.
work commitments beyond
Mm,
office hours. Okay, that's one thing I try to do. And the second thing is, in fact, when I say no, I
mm.
often try to say no with a very explicit reason. It's not just I am busy. Oh,
Absolutely.
I have to
Absolutely.
pick up kids. Sorry,
Mm.
I have to be at home. I have
Nice.
home, family commitment. I make it
Mm.
also very clear why I am saying no. I
Absolutely.
think these
Absolutely.
are the two ways that I think I have tried to sort of make it clear that I'm totally fine saying no to you for these reasons. It's not
These
because I
reasons.
have another
Absolutely.
talk, therefore I'm saying no to you.
Absolutely.
It's
Absolutely.
not because I have another paper, because I'm actually have work at family. I have to take care of kids. I have
Absolutely.
to
Absolutely.
drop them somewhere. So I make it a point to be very explicit about those. Okay.
Absolutely. Absolutely.
And But I think that culture is still lacking.
Lacking. Oh, yes.
That culture is still lacking, and although it's slowly changing,
Yeah.
as we
Yeah.
have all noticed, it is slowly changing.
Mm.
uh, that is sort of one small way I I try to
No, no, this is something
convey.
very, very, very important, because I'm very sure this is probably true for everybody. Fatherhood really changes the man, positively. I mean to say, and somehow in our kind of lineage, in terms of not only just in India, in various different places, it is always just the woman who is entrusted with the development of a kid, especially in the growing up years,
Mhm.
and somehow that has not been emphasized too much, right? Where
Mhm.
the father has an equally important role to play in upbringing of the children, as much
Yeah,
as,
yeah,
let's say, the mother. And
absolutely.
I'm very, yeah, yeah, I'm very glad that this has been actually discussed. As I mentioned, I wanted it to be also kind of noted, because I think more men should do that, in my opinion.
Yeah, 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 absolutely. Yeah.
It
And
should be
I mean,
normalized.
when I decline invitations again, especially
Mm,
out of Bangalore for
mm,
various
mm.
talks, again say because of family commitments, I'm sorry, I'm unable to take it up.
Absolutely, absolutely.
Um,
No,
and
no, this is
and
something which should be, as I mentioned, it should be normalized, and
mm, and people understand. Many of them do
people
understand.
understand. Absolutely,
Yeah,
people
many
do
of them
understand.
do understand.
Mm,
These issues. But you are also right that if you were to compare, maybe sort of any of the among the if you compare,
mm,
if you look at the trajectory of a typical scientist, let's say
mm,
a well-known scientist from India, and probably
mm.
even abroad, I mean even more so in abroad, I
Yeah.
suppose. um, let's say going back 2 or 3 decades in time.
Mm, mm.
Okay. They were probably would have taken assignments and talks and other
Yeah.
things over the
Yeah.
weekends, over without any probably family constraints. Of course, I'm sure
Guys.
there were exceptions back then too.
Yeah. Yeah.
And I think the current generation like ours,
Mm,
I
mm.
think we are actually, in fact, I have been told, why don't you guys say no so many times? but they
Yes.
don't realize that the generation has changed, and
Absolutely. Absolutely correct.
the values that we now adhere to has changed a lot. Whereas the
Absolutely.
typical
Absolutely.
scientist back then was mostly male, and
Yes. Yes.
who had a non-working
Mm.
spouse.
Yes.
So,
Yes.
and it was accepted, it was desirable back then to be only
Exactly.
be engaged in your science work, but that is not the case anymore. I
Not
think
the
that
case
should not
now.
be the case, and that should not be the norm,
Norm.
and that should
Absolutely.
absolutely change, I think.
No,
Yeah.
I totally agree with you. I totally agree with you. Thanks for sharing this aspect of it. So we'll now
And in
broaden.
fact,
Yeah,
just
yeah,
last,
yeah.
just I have like
Mm.
three talks invitation that I have to somehow figure out a way to say no in convoluted ways.
No, that's
Just too
always a
hard to
tough thing.
travel
But
outside
exactly. Yeah.
Bangalore for talks. And,
Yeah,
yeah.
in fact, that's another constraint because if the transportation actually is somehow even more efficient, things would
Hmm.
be slightly better. But in India, it's still under process in that sense. So we'll also kind of touch upon a little bit about going a little bit broader in terms of how science in India can probably be improved, especially in terms of research ecosystem. I also have read and also heard you talking very vociferously about supporting students. By the way, Vishwesha is very active on Twitter. I would anyway link his Twitter account in the show notes. So please do follow him. In fact, there are some very insightful things what he has to say on his Twitter timeline. So, Vishwesha, this is a kind of a burning question in Indian academia, especially in research community, of supporting people who work in research arena. Not only faculty, but also students and other people. Uh, there is still a very important requirement of us expanding this avenue and supporting the students. Uh, Particularly people who do PhDs, because they are really taking a trade off in their lives, right? Because they could have taken an option and earned a bit more, not only earning but also have a very different lifestyle altogether.
Yeah.
How should we somehow manage to improve? Of course, monetary aspect is one point, but including monetary and other things, could you please tell us how can we kind of improve the situation?
Yeah, I think it's a very difficult question. As
Mm, mm.
individual faculty members, we do not have full control over the systemic issues.
Absolutely, absolutely.
Systemic issues, as for example, the one that you mentioned, the
Mm,
monetary issue, right?
mm,
For example, what do you do? What can you
mm.
really do beyond some basic support
Yeah,
if salary doesn't come for 6 months? There's only, okay, I can maybe support for 2 months, but what do you do beyond that? I
absolutely right.
think there is going to be some fundamental limitations to what we can do when there are larger systemic issues.
Issues, absolutely.
Of course, I am hoping that those on the sort of senior science administrations who have
Yeah.
the power and the privilege to influence this are working very hard to solve these problems, and we must,
Mm.
in our individual capacity, hopefully we can continue to pressurize them.
Yes,
Okay.
yes.
um, and but coming back to sort of what we can do within a
Mm,
department, for example, where we have some more control within our own labs, right?
mm,
I think there are still a lot of things we can do
mm,
to make the sort of the lives of the PhD students better.
mm,
Not
mm.
because they sacrificed something and came here. You know, Independent
Absolutely.
of that, we need to make sure that our peers and our colleagues, they're all our colleagues, peers in some ways, right? Scientifically, they are colleagues,
Absolutely.
and
Absolutely.
we are working with them on a day-to-day basis. And so they need to be taken care of, right?
Care of.
In terms of
Absolutely.
the work. So, we can certainly do is, can we improve the working environments
Mm,
within
mm.
our own labs, within our own departments? That is certainly something that all of us can do, right? Um, and while of course, it's obvious, seems like an obvious thing that one must
Mm.
do, but what does it require one to do is the not so obvious
Not so
part.
obvious part of it. Absolutely.
And
Absolutely.
there will be no one answer either, I suppose, right? But can we ask ourselves what can we do to improve the working
mm,
environment within our own labs. Can we as faculty have play an active role in doing so? For
mm,
example,
mm,
talk to students, find out what do they want, what are their where are they finding
mm.
issues that needs to be resolved, uh, that we can actually resolve
Resolve.
within the
Yeah.
laboratory setting and
Setting.
within the departmental settings. Can we set
Mm,
up some semi-formal, informal
mm.
structures to again support students?
Absolutely.
For example, peer support groups, for
Mm,
example,
mm, mm,
peer support. We only need to take initiatives and set
mm,
things in motion. By and large, things work, right? But the
mm.
challenge often is, how do we set things in motion?
Emotion.
Okay.
Absolutely. Absolutely.
PhD is sometimes a very difficult and can become very strenuous, especially
Mm,
as students get towards the final years. How do we help them at various stages? I think if there is a constant dialogue and willingness to improve the work environments within the labs, within the
mm.
departments, is something that each of us can try our best to
Can
do.
try to.
And
Absolutely.
even there, I see that in various places there could be resistances from colleagues within the department.
Mm,
Okay.
mm,
Okay, so in those cases you do hit some roadblocks,
mm,
but
mm.
it should never really stop us from working hard to improve
Working hard.
the mentor-mentee relationships. What all we can do to improve the working environments better. Okay,
Absolutely.
and in fact, by and large, I think what I do is I don't do anything.
Mm.
I don't do much. I don't. I think students by the stage that they are here, they are basically adults.
Yes.
They need broad directions
Mm,
and broad
mm, mm.
guidance. How they
Absolutely.
man in my philosophy is how they manage their daily lives,
Mm.
their daily work progress. It's entirely up to them.
Up to them.
You know,
Same here.
the philosophy that I follow is that can we provide the long-term guidance
Mm,
and long-term mentoring? Can we set up systems in place to sort of make sure they don't fall behind on the long-term
mm,
goals,
mm.
but we don't manage them on a day-to-day basis? I think
Married.
this is the
Absolutely.
combination and philosophy I try to follow. I'm sure I have also made mistakes and I have also
Mm. No, that's all.
gone
It's
wrong.
always a learning process. Always a learning process. Absolutely right.
And again, it's also possible that I have actually heard this or heard about this also.
Mm,
In fact, for some students, this actually doesn't work well.
mm,
For some
mm,
students, they actually need to be handled on a much more finer time scale.
mm,
And it's possible that in a laboratory setting like where there is less management on a day-to-day basis, some students don't do well, and we must be open to the possibility of accepting that and see if we can manage
see,
that as well. Okay.
absolutely. Absolutely.
So I think broadly trying to facilitate the growth of PhD students in their towards their aspirations and guiding them
Mm.
for research and guiding them for career must be our broad goals.
Broad
That's the
growth.
philosophy I
Absolutely.
try to follow.
Wonderful. Wonderful. So, to again step away from this aspect and go a little further, I also have seen you have some kind of interest in philosophy of science too,
Hmm.
because I've read some of the things what you have written, very beautifully articulated. I am also linking that in the show notes, and one of the aspect you have also written about is the philosophy of science and the viewpoints and other things. So, how did you develop that interest, Shwesha? You've been always interested in that.
Yeah, I think that comes from sort of slightly philosophical upbringing I had,
Mhm,
where I think if you basically if you think of Indian philosophical systems,
mm, mm,
all of them, independent of which specific sort of philosophy one follows,
mm.
there is a strong focus on understanding uh, the knowledge base, the base. What is the source
Uh,
of knowledge? Okay,
Absolutely.
so-called Pramana
Epistemological
Shastra,
aspect.
epistemology. They're
Mm.
thinking on what constitutes, what are called pramanas, right? So I think
Pramanas.
I had
Exactly.
some training on that
Mm,
from a religious and philosophical point of view,
mm, mm,
and in some sense, the scientific work was a natural
mm.
extension
Extension of
of
that.
that.
Absolutely.
Huh?
Yes.
And and during my PhD, during my uh, postdoc as well, and continuing to later as well, with many of my friends, we we often used to discuss how do we arrive at these conclusions? How did we
mm,
understand this better? Okay.
mm, mm,
I think that was a constant sort of, for example, just to give a specific example here, one of my friends was working on string theory and gravity.
mm, mm,
And also, he had a really a remarkable understanding of broadly the high energy physics literature. Okay.
mm, mm,
Now that's, the moment you sort of go to those scales,
mm,
nothing
mm.
is really visible to you anymore, right?
Exact. Yeah. Yeah.
Right,
Yeah.
but how do you really arrive at conclusions was
Correct.
something that always fascinated me.
Mm, mm,
Okay.
mm,
And we used to discuss a lot. Okay.
mm.
And that all those discussions then led me to sort of more formal reading about books on philosophy
Wo-
of science,
Nice.
uh,
Nice.
which, I had this sort of, practice of reading a book for roughly 30 minutes to 1 hour every night during my PhD
Mm,
days. I
mm,
wish
mm.
I can somehow bring that back now. So I read a
Okay.
lot of books on, you know, uh, you know, Himalaya in particular, and also
Uh, uh,
also on philosophy of science.
nice. Nice.
Yeah.
Fantastic.
So that's
Fantastic.
sort of, my sort of interest, and I teach that in a very, very basic level in one of the courses here.
Wonderful.
Not
That's
at the,
very important.
we have a course called Principles of Scientific Thinking.
Thinking. Nice.
There I teach some modules on, I don't teach the full course, but I teach
Mm,
that
mm.
module on philosophy of science.
Wonderful, wonderful. In fact,
Mm.
I keep emphasizing this throughout the podcast, in also in my writing in blogs and all, that that emphasis on philosophy and history is very critical to get a context, as we were discussing about.
Mhm.
Somehow, many a times students lose out interest in various things because they lose out the context. Because if
Yeah.
it is put in a slightly broader framework, they see the points in the lattice, so to speak.
Mm.
And then they know the connections and the
Mhm.
relevance of some particular thing. And in fact, I would urge the listeners to have a look at the show notes, especially on the articles what Vishwesha has written. It's really worth
Yeah, they're
reading.
extremely basic, though. There are fantastic
No, no,
books
that's
available.
important. In fact, that's where
Uh,
you can get started. And that is the language one should also introduce philosophy, in my opinion. Many a times, philosophy is made too complicated and too complex, and somehow people again lose out. Again, they lose out the context, so to speak.
mhm.
If it is put in the framework of what you're already studying and learning,
Mhm.
it is equally critical. So,
Mhm.
Vishwesha, we'll come to slightly more fun part of the discussion. Of
Okay.
course, everything was fun, but we'll actually switch the languages now. I know that Vishwesha also writes in Kannada. If you look up, for example, his web page, you'll see very beautiful summaries of some of his papers in Kannada. That is something fantastic. In fact, I would urge many people to do that in their own kind of mother tongue, where you can also bring in the scientific language and make it a little bit more broader in the context of what you have been doing. And so, Vishwesha, please tell us more about your motivations, your research interest in the beautiful Kannada.
ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡೋದು ಯಾವಾಗಲೂ ಚೆನ್ನಾಗಿದ್ದೇ ಇರುತ್ತೆ.
ಹೌದು ಹೌದು.
So,
So
so in fact,
I would actually break the rule. In fact, since I speak in Kannada, I would probably be also be able to converse a little bit with Vishwesha. Unlike the other languages, of course, Hindi is something I can speak, but in this case, Vishwesha, ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡು.
ಸರಿ 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 ಹಾ. ಸೊ ಸೊ ಆಕ್ಚುಲಿ ಕನ್ನಡದಲ್ಲಿ ಸೈನ್ಸ್ ಮಾತಾಡೋದು ನಾನೇನು ಹೆಚ್ಚು ಪ್ಲಾನ್ ಮಾಡಿರೋ ಕೆಲಸ ಅಲ್ಲ ಇದು.
ಹೌದು.
ಸೊ ಒಂದ್ ರೀತಿ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ, ಹೇಗಾಗಿರೋದು ಅಂದ್ರೆ, ಸುಮಾರು ಜನ ಕರೀತಾರೆ, ಕರೆದ್ಬಿಟ್ಟು
ಹ್ಮ್
ಸರ್ ಟಾಕ್ ಕೊಡ್ತೀರಾ ಅಂತ ಕೇಳ್ತಾರೆ.
ಹ್ಮ್
ಆ ಕನ್ನಡದಲ್ಲೇ ಕೊಡ್ತೀರಾ ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ ಹ್ಞೂ
ಹ್ಮ್
ಅಂತ ಹೇಳ್ತೀನಿ. ಸೊ ಹಾಗಾಗಿನೇ ನಾನೇನು ಕೆಲವು ವಿಡಿಯೋಸ್ ಇವೆ, ಕೆಲವು ಆರ್ಟಿಕಲ್ಸ್
ಹೌದು
ಇವೆ.
ಹೌದು
ಸೊ
ಹೌದು
ಅವೆಲ್ಲಾನು ಆಗಿರೋದು, ಕೆಲವರು ಕರೆದು ಟಾಕ್ಸ್ ಕೊಡಿ ಅಂದಾಗ, ಮಕ್ಕಳ ಜೊತೆ ಮಾತಾಡಿ ಅಂದಾಗ,
ಹ್ಮ್
ಸೊ ಅಂತ ಸಂದರ್ಭದಲ್ಲಿ ಆಗಿರೋದೇ ಹೊರತು ನಾನೇನ್ ಹೆಚ್ಚಕ್ಕೆ ಅದಕ್ಕೋಸ್ಕರ ವಿಶೇಷವಾದ ಪ್ರಯತ್ನ
ಅದಕ್ಕೋಸ್ಕರನೇ.
ಪಟ್ಟು
ಹೌದು ಹೌದು
ಮಾಡ್ಲೇಬೇಕು ಅಂತ ಏನ್ ಮಾಡಿರೋದಲ್ಲ.
ಹೌದು
ಆತರ
ಹೌದು.
ಮಾಡ್ಬೇಕಾದ್ರೆ ಒಂದೆರಡು ಎಕ್ಸ್ಟ್ರಾ ಕೆಲಸ ಮಾಡಿರ್ಬೋದು. ನೀವ್ ಹೇಳ್ದಂಗೆ
ಹ್ಮ್
ಕೆಲವು ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಗಳನ್ನ
ಹ್ಮ್
ಕನ್ನಡದಲ್ಲಿ ಅನುವಾದ ಮಾಡಿ ಇಟ್ಕೊಂಡಿದೀವಿ.
ಹ್ಮ್
ಅದೆಲ್ಲಾನು ತುಂಬಾ ಸಿಸ್ಟಮ್ಯಾಟಿಕ್ ಆಗಿ ಮಾಡಿಲ್ಲ. ಯಾವ ತುಂಬಾ ಸ್ವಲ್ಪ ಜನರಲ್ ಆಗಿರುತ್ತೋ,
ಜನರಲ್ ಆಗಿದೆಯಾ? ಹೌದು
ಯಾವ
ಹೌದು
ಜನರಲ್, ನಮ್ಮ ಸೈಂಟಿಫಿಕ್ ಪೇಪರ್ಸ್ ಕೆಲವು ತುಂಬಾ ಟೆಕ್ನಿಕಲ್ ಇರುತ್ತಲ್ವಾ, ಎಲ್ಲಾನು
ಹೌದು
ಜನರಲ್
ಹೌದು
ಇಂಟ್ರೆಸ್ಟ್ ಇರೋಲ್ಲ. ಯಾವ್ದು ಸ್ವಲ್ಪ ಜನರಲ್ ಇಂಟ್ರೆಸ್ಟ್ ಅಂತ ಇರುತ್ತೋ ಅಂಥದನ್ನ ಮಾತ್ರ ಕೆಲವೆಲ್ಲ ಮಾಡಿಟ್ಟಿದ್ದೀನಿ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಹೆಚ್ಚು ನಾನು ತುಂಬಾ ಔಟ್ ಆಫ್ ದ ವೇ ಹೋಗಿ ಮಾಡಿರುವಂತ
ಹೋಗಿ
ಕೆಲಸ.
ಮಾಡೋದು. ಹೌದು.
ಉದಾಹರಣೆಗೆ ಹೋದ್ವಾರ ಯಾವುದೋ ಒಂದು ಸ್ಕೂಲ್ ನಿಂದ ಒಂದೇನೋ ಒಂದು ಕರೆದಿದ್ರು, ಯಾರೋ ಒಂದು ಮಾತಾಡಕ್ಕೆ, ಟೀಚರ್ಸ್ ಬಗ್ಗೆ ಬಂದು ಮಾತಾಡಿ ಅಂತ. ಅದು ಫುಲ್ ಕನ್ನಡದಲ್ಲೇ, ಅಲ್ಲೆಲ್ಲ ಟೀಚರ್ಸ್ ಕನ್ನಡ ಬರೋದು. ಸೊ ಅದರಿಂದ ಸಂಪೂರ್ಣವಾಗಿ ಒಂದು ಸಂಭಾಷಣೆ ಫುಲ್ ಕನ್ನಡದಲ್ಲೇ ಮಾತಾಡೋದಾಯ್ತು.
ವೆರಿ
ಸೊ
ನೈಸ್.
ಆ ರೀತಿ ಕನ್ನಡದಲ್ಲಿ ಸೈನ್ಸ್ ನ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡೋದು ಅಂತ ವಿಶೇಷವಾಗಿ ನಾನು ಪ್ರಾಕ್ಟೀಸ್
ಪ್ರಾಕ್ಟೀಸ್
ಮಾಡಿರೋದು.
ಮಾಡಿಲ್ಲ. ಹೌದು ಹೌದು. ಅರೆ
ಆದ್ರೆ
ಈಗ
ಒಂದೇನಾಗತ್ತೆ,
ಬೆಂಗಳೂರು, ಈಗ ಬ್ಯಾಂಗ್ಳೂರ್ ನ್ಯಾಷನಲ್ ಕಾಲೇಜ್ ಬೆಂಗಳೂರು ಫೋರಂ ಅಲ್ಲಿ ತುಂಬಾನೇ ಜನ ವಿಜ್ಞಾನಿಗಳು ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡಿದ್ದಾರೆ, ಇನ್ಕ್ಲೂಡಿಂಗ್ ರಾಧಮ್ ನರಸಿಂಹ ಅವರು. ಮತ್ತೆ ಐ ಥಿಂಕ್ ತುಂಬಾ ಜನ, ನೀವು ಪ್ರಾಬ್ಲಿ ಮಾತಾಡಿದ್ದೀರಾ ಅನ್ಸತ್ತಲ್ವಾ ಅಲ್ಲಿ?
ಅಲ್ಲಲ್ಲ,
ಹಾ.
ಇಲ್ಲಿ ಕೆಲವು ಕನ್ನಡ ಗ್ರೂಪ್ಸ್ ಇವೆ, ಕನ್ನಡ
ಓಕೆ.
ಸೈನ್ಸ್ ಗ್ರೂಪ್ಸ್. ಅವರನ್ನು ನಮ್ಮ ಸುಮಾರು 3-4 ಜನ ಟಾಕ್ಸ್ ಕರೆದಿದ್ರು,
ವಂಡರ್ಫುಲ್.
ಅವಾಗ ಮಾತಾಡಿದ್ದೀನಿ. ಆಮೇಲೆ ಅಲ್ಲಿ ಇಲ್ಲಿ ಕೆಲವೆಲ್ಲ ಎಲ್ಲಾನು ಇದೊಂದು 4-5 ರೆಕಾರ್ಡ್ ಆಗಿರ್ಬೋದು. ಇನ್ ಕೆಲವೆಲ್ಲ
ಹೌದು.
ಸ್ಕೂಲ್ಗಳಿಗೆ ಹೋದಾಗ ಮಾಡಿದಾಗ ಅಲ್ಲೆಲ್ಲ ನಾನು ಎಷ್ಟು ಸಾಧ್ಯ ಆಗುತ್ತೋ ಕನ್ನಡದಲ್ಲೇ ಟ್ರೈ ಮಾಡ್ತೀನಿ. ಎಸ್ಪೆಷಲಿ ಈಗ
ವಂಡರ್ಫುಲ್.
ಕನ್ನಡ ಬರೋ ಮಕ್ಕಳಾಗಿದ್ರೆ,
ಮಕ್ಕಳಾಗಿದ್ರೆ.
ಕನ್ನಡ
ಹೌದು.
ಮೀಡಿಯಂ ಸ್ಕೂಲ್ ಆಗಿದ್ರೆ,
ಹ್ಮ್ ಹ್ಮ್.
ಅಲ್ಲೆಲ್ಲ ಅಂತೂ ನಾನು ಸಾಮಾನ್ಯ ಕನ್ನಡದಲ್ಲೇ ಮಾತಾಡೋದು.
ಹೌದು
ಆತರ
ಹೌದು.
ಹೋದಾಗೆಲ್ಲ
ಇನ್ಫ್ಯಾಕ್ಟ್ GS ರಂಗನಾಥ್ RRI ಅಲ್ಲಿ ಒಬ್ರು ಸೈಂಟಿಸ್ಟ್ ಇದ್ರು. ಅವರು
ಗೊತ್ತು.
ತುಂಬಾನೇ ಒಳ್ಳೆ ಕನ್ನಡದ ಕೈಂಡ್ ಆಫ್ ಲೆಕ್ಚರ್ಸ್ ಕೊಡ್ತಾ ಇದ್ರು.
ಹ್ಮ್
ಸೈನ್ಸ್
ಹ್ಮ್
ಏನೋ
ಹ್ಮ್ ಹ್ಮ್
ತುಂಬಾ ಅವ್ರ ಎಕ್ಸೈಟ್ಮೆಂಟ್ ಅದೆಲ್ಲ ನೋಡಿದ್ರೆ ತುಂಬಾನೇ ಇಟ್ಸ್ ವೆರಿ ವೆರಿ ಇನ್ಸ್ಪೈರಿಂಗ್ ಆತರ.
ಹ್ಮ್ 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 ಸರಿ ಸರಿ. ಹಾ.
ಸೊ ಜನರಲಿ ಸೈಂಟಿಸ್ಟ್ ಆಗೋದು ಮೋಟಿವೇಶನ್ ಏನ್ ಬಂತು ವಿಶ್ವೇಶ್ ಅವರೇ? ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ ನೀವು ಯಾಕೆ
ಆ,
ಸೈಂಟಿಸ್ಟ್ ಆದ್ರಿ?
ಕನ್ನಡದಲ್ಲೇ ಆ, ಇವಾಗಲೇ ಹೇಳಿರೋ ಹಾಗೆ ಆ, ಒಂದು ಏನೋ ಒಂದು ವಿಶಿಷ್ಟವಾಗಿ ಕಲಿಯೋಣ ಅಂತ.
ಹ್ಮ್ ಹ್ಮ್
ಏನೋ ನಮ್ಗೆ ಯಾವ ಸಬ್ಜೆಕ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದ ನಮ್ಗೆ ಒಂಥರ ಖುಷಿ ಸಿಗುತ್ತೋ ಆ
ಹ್ಮ್.
ಒಂದು ಸಬ್ಜೆಕ್ಟ್ ಕಲಿಬೇಕು, ಅದನ್ನ ಡೀಪ್ ಆಗಿ ಕಲಿಬೇಕು ಅಂದ್ರೆ ಸೈಂಟಿಫಿಕ್ ಕೆರಿಯರ್ ಒಂದು ಒಳ್ಳೆ ಕೆರಿಯರ್.
ಹೌದು
ಸೊ
ಹೌದು.
ಆ ಒಂದು ಇಂಟ್ರೆಸ್ಟ್ ಇಂದ ಕಲಿತಾ ಬಂದಿರೋ. ಸ್ವಲ್ಪ ನಂಗೆ ಮೊದ್ಲಿಂದನೂ ಸ್ವಲ್ಪ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ನಲ್ಲಿ ಇಂಟ್ರೆಸ್ಟ್ ಇತ್ತು.
ಇಂಟ್ರೆಸ್ಟ್
ಸೊ
ಇತ್ತು. ಹೌದು.
ಸೊ ಫಿಸಿಕ್ಸ್ ನಲ್ಲಿ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ತುಂಬಾ ಬಳಕೆ ಆಗತ್ತು, ಆ ರೀತಿ ಫಿಸಿಕ್ಸ್ ನಲ್ಲಿ ಇಂಟ್ರೆಸ್ಟ್ ಬಂತು. ಆಮೇಲೆ ಫಿಸಿಕ್ಸ್ ಮತ್ತೆ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ಸೇರಿ ಈಗ ಬಯಾಲಜಿ, ನೇಚರ್ ನ ಅರ್ಥ
ನೇಚರ್.
ಮಾಡ್ಕೊಳಕ್ ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ
ಹೌದು ಹೌದು.
ಇವೆರಡು.
ಈ ಫಿಸಿಕ್ಸ್ ಮತ್ತು ಬಯಾಲಜಿನ ಕಂಬೈನ್ ಮಾಡಿ ನೀವು ಕೆಲಸ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ ನಿಮ್ಗೆ ತುಂಬಾನೇ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಹುಶಃ ನೀವು ನೋಡ್ತೀರಾ ಅನ್ಸುತ್ತೆ ನೀವು ರಿಸರ್ಚ್ ಅಲ್ಲಿ.
ಹೌದು ಹೌದು ಹೌದು.
ಈಗ
ಅದ್ರಲ್ಲಿ ಒಂದ್ ಹೇಳಿ ಹೇಳಿ.
ಸೊ ಆ ತರ ರಿಸರ್ಚ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಯಾವ ತರ ಎಜುಕೇಶನ್ ಟ್ರೈನಿಂಗ್ ಇರಬೇಕು? ಸ್ವಲ್ಪ ಅದ್ರ ಬಗ್ಗೆ ಹೇಳಿದ್ರೆ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಸ್ಟೂಡೆಂಟ್ಸ್
ಒಂದ್ ರೀತಿ ಇವಾಗ ಬಯಾಲಜಿನ ಸ್ವಲ್ಪ ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ಥಿಂಕಿಂಗ್ ಇಂದ ಆ,
ಹ್ಮ್
ಆ, ಆ, ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂತ
ಹ್ಮ್
ಇಂಟ್ರೆಸ್ಟ್ ಇರೋರಿಗೆ ಯಾವುದೇ ಒಂದು ಸ್ವಲ್ಪ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ಚೆನ್ನಾಗಿ ಬರುವಂತ ಯಾವುದೇ ಒಂದು ಸಬ್ಜೆಕ್ಟ್ ಅಲ್ಲಿ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಇದ್ರೆ ಹೆಲ್ಪ್ ಆಗತ್ತೆ. ಫಿಸಿಕ್ಸ್
ಹ್ಮ್
ಆಗಿರ್ಬೋದು,
ಹ್ಮ್.
ಮ್ಯಾಥ್ಸ್ ಆಗಿರ್ಬೋದು, ಅಥವಾ ಅದರ ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಸಹಿತ ಆಗಿರ್ಬೋದು,
ಹೌದು
ಅಥವಾ
ಹೌದು.
ಇಂಜಿನಿಯರಿಂಗ್ ಸಹಿತ ಆಗಿರ್ಬೋದು. ಆ ಒಂದು ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಇದ್ರೆ ಆ ನಾವು ಸಾಮಾನ್ಯವಾಗಿ ನಮ್ಮ ನೇಚರ್ನ, ಫಿಸಿಕಲ್ ನೇಚರ್ನ
ಹ್ಮ್
ಸಾಮಾನ್ಯವಾಗಿ ಹೇಗೆ ಮ್ಯಾಥಮ್ಯಾಟಿಕಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು ಅಂತ ಅದ್ರಲ್ಲಿ ಚೆನ್ನಾಗಿ ಕಲ್ತಿರ್ತೀವಿ ನಾವು.
ಕಲ್ತಿರ್ತೀವಿ. ಹೌದು
ಆ
ಹೌದು.
ಒಂದು ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಇಂದ ಬಂದ್ಮೇಲೆ ಆ ಒಂದು ಟೂಲ್ಸ್ ಚೆನ್ನಾಗಿ ಹಿಡಿತಾ ಬಂದಿರೋದ್ರಿಂದ ಬಯಾಲಜಿ
ಹ್ಮ್.
ಕೂಡ ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ ಸುಲಭ ಆಗತ್ತೆ.
ಸುಲಭ ಆಗುತ್ತೆ.
ಅದೇ ರೀತಿ ಯೋಚನೆ ಮಾಡಿ. ಸೊ ನಾನ್ ಹೇಳೋದೇನಪ್ಪಾ ಅಂದ್ರೆ, ಬಯಾಲಜಿನಲ್ಲಿ ಆಸಕ್ತಿ ಇಟ್ಟುಕೊಂಡು ಇದ್ಯಾವ್ದಾದ್ರು ಒಂದು ಸಬ್ಜೆಕ್ಟ್ ಚೆನ್ನಾಗಿ ಕಲ್ತ್ಕೊಂಡ್ರೆ
ಕಲ್ತ್ಕೊಂಡ್ರೆ
ಈ ತರ ಇಂಟರ್
ಹೌದು.
ಡಿಸಿಪ್ಲಿನರಿ ಏರಿಯಾನಲ್ಲಿ ಮುಂದೆ ಬರ್ಬೋದು.
ಹ.
ಅಫ್ಕೋರ್ಸ್ ನಾವು ತುಂಬಾ ಹೈಸ್ಕೂಲ್ ನಲ್ಲೇ ಇರ್ಬೇಕಾದ್ರೆ, ಅಂಡರ್ ಗ್ರಾಡ್ ನಲ್ಲೇ ಇರ್ಬೇಕಾದ್ರೆ ಅಷ್ಟು ಪ್ಲಾನಿಂಗ್ ಎಲ್ಲ ಮಾಡಕ್ ಆಗೋದಿಲ್ಲ. ಎಲ್ಲ
ಮಾಡಕ್ಕಾಗಲ್ಲ. ಹೌದು
ಹೋಗ್ತಾ ಹೋಗ್ತಾ ನಮ್ಗೆ ಯಾವ ರೀತಿ ಅವಕಾಶಗಳು ಸಿಗುತ್ತೆ, ಯಾವ ರೀತಿ ಸಂದರ್ಭಗಳು ಸಿಗುತ್ತೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ನಮ್ ಇಂಟ್ರೆಸ್ಟ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ.
ಹೌದು ಹೌದು.
ಸೊ ಇದನ್ನೆಲ್ಲ 100% ಯಾರಿಗೂ ಪ್ಲಾನ್ ಮಾಡಕ್ ಸಾಧ್ಯ ಇಲ್ಲ. ಒಟ್ಟಲ್ಲಿ ಸ್ವಲ್ಪ ಹೊಸ ಹೊಸ ವಿಷಯನ ಕಲಿಯೋದಕ್ಕೆ ನಮ್ಮ ಮನಸ್ಸು ಮುಕ್ತವಾಗಿರ್ಬೇಕು.
ಹ್ಮ್ ಹ್ಮ್.
ಅದ್ಯಾವ್ದೋ ನನಗ್ ಬೇಡ, ಆ ಸಬ್ಜೆಕ್ಟ್ ನಂಗೆ ಇಂಟ್ರೆಸ್ಟ್ ಇಲ್ಲ, ಅಯ್ಯೋ ಆ ಸಬ್ಜೆಕ್ಟ್ ಅಂತ ಮುಖ್ಯ ಅಲ್ಲ ಅಂತ ಒಂದು ಸಂಕುಚಿತ ಮನೋಭಾವನೆ ಇರಬಾರ್ದು.
ಹೌದು ಹೌದು. ಅದು ತುಂಬಾನೇ ಪರ್ಟಿನೆಂಟ್ ಇದು ಪಾಯಿಂಟ್. ಯಾಕಂದ್ರೆ ಒಂದರಲ್ಲಿ ಆಳವಾಗಿ ಆಲೋಚನೆ ಮಾಡಿ ಆ ಆಲೋಚನೆನ ವೇರಿಯಸ್ ಡಿಫ್ರೆಂಟ್ ಪ್ಲಾಟ್ಫಾರ್ಮ್ಸ್ ಅಂದ್ರೆ ಹಲವಾರು ಕ್ವೆಶ್ಚನ್ಸ್ಗೆ ಅಥವಾ ಪ್ರಶ್ನೆಗಳಿಗೆ ಉಪಯೋಗಿಸೋದ್ರಿಂದ ಅದರ ಡೆಪ್ತ್ ಮತ್ತೆ ಬ್ರೆಡ್ತ್ ಎರಡು ಕವರ್ ಆಗುತ್ತೆ ಆಗ.
ಹೌದೌದು
ತುಂಬಾ
ಹೌದೌದು
ತುಂಬಾನೇ
ಕರೆಕ್ಟ್. ಇವಾಗ ನಾವು ಉದಾಹರಣೆಗೆ ನಾವು ನಮ್ಮ ಲ್ಯಾಬ್ ನಲ್ಲಿ ಯೂಸ್ ಮಾಡೋ ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ಟೆಕ್ನಿಕ್ಸ್ ಇಂದ ಸೆಲ್ಸ್ ನು ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು. ಸೆಲ್ಸ್ ಬಗ್ಗೆ ಉದಾಹರಣೆಗೆ ಇತ್ತೀಚೆಗೆ ಹೋದ ವರ್ಷ ಒಂದು ಪೇಪರ್ ಪಬ್ಲಿಷ್ ಮಾಡಿದ್ವಿ. ಅದರಲ್ಲಿ ಏನೋ ನಿಮ್ಯಾನ್ಸ್ ನಲ್ಲಿ ನಮ್ಮ ಕೆಲವು ಕೊಲಾಬರೇಟರ್ಸ್ ಇದ್ದಾರೆ, ಸ್ನೇಹಿತರಿದ್ದಾರೆ. ಅವರು ಬ್ರೈನ್ ನಲ್ಲಿ ಇರೋ ಸೆಲ್ಸ್ ಹೇಗೆ ಮೂವ್ ಆಗತ್ತೆ ಅಂತ ಅವ್ರ ಡೇಟಾ ಇತ್ತು ಅವ್ರ ಹತ್ರ. ಸೊ ಅವ್ರಿಗೆ ಕೆಲವ್ರಿಗೆ ಮೆದುಳಿನ ಕಾಯಿಲೆ ಬಂದು ಅದಕ್ಕೆ ಮಾನಸಿಕ ರೋಗ ಇರೋದು ಕೆಲವು ಡೇಟಾ ಇತ್ತು. ಇನ್ ಕೆಲವರು ಚೆನ್ನಾಗಿರೋರು, ಅವ್ರಿಗೆ ಯಾವುದೇ ರೋಗಗಳು ಇರ್ಲಿಲ್ಲ. ಸೊ ಅವರಿಬ್ಬರಲ್ಲಿರೋ ಬ್ರೈನ್ ಸೆಲ್ಸ್ ಬೇರೆ ಬೇರೆ ರೀತಿ ಮೂವ್ ಆಗತ್ತೆ, ಬೇರೆ ಬೇರೆ ರೀತಿ ನಡೆಯುತ್ತೆ. ಅದನ್ನ ನಾವು ಬ್ರೌನಿಯನ್ ಮೋಷನ್ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದೆ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಅದನ್ನ ಕ್ಯಾರೆಕ್ಟರೈಸ್ ಮಾಡುತ್ತೆ.
ವಾವ್. ಸೊ ಅದೇನು ಸಬ್ ಡಿಫ್ಯೂಸಿವಾ ಸೂಪರ್ ಡಿಫ್ಯೂಸಿವಾ ಏನಾಗುತ್ತೆ ಅದು?
ಎಕ್ಸಾಕ್ಟ್ಲಿ ಒಂದು ಡಿಫ್ಯೂಸಿವ್ ಇದೆ, ಒಂದ್ ಸ್ವಲ್ಪ ಸೂಪರ್ ಡಿಫ್ಯೂಸಿವ್ ಇದೆ.
ಸೂಪರ್. ವಾವ್. ಓಕೆ.
ಅಂದ್ರೆ ನಂಗೆ ನಾನು ಹೆಲ್ದಿ ಸೆಲ್ಸ್ ಡೈರೆಕ್ಟೆಡ್ ಆಗಿರುತ್ತೆ, ಸೂಪರ್ ಡಿಫ್ಯೂಸಿವ್ ಆಗಿದೆ. ಅನ್ಹೆಲ್ದಿ ಸೆಲ್ಸ್ ರೋಗಿಷ್ಠರಾಗಿರ್ತಾರಲ್ಲ ಅವ್ರ ಸೆಲ್ಸ್ ಸ್ವಲ್ಪ ಕ್ಲೋಸ್ ಟು ಡಿಫ್ಯೂಸಿವ್ ಆಗಿದೆ.
ಓ, ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್.
ಸೊ ಅಂದ್ರೆ ಒಂದ್ ರೀತಿ ನಾವು ಈ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ಕಲ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನ ಚೆನ್ನಾಗಿ ಕಲ್ತ್ಕೊಂಡ್ರೆ, ಆಮೇಲೆ ಫಿಸಿಕ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಚೆನ್ನಾಗಿ ಕಲ್ತ್ಕೊಂಡ್ರೆ ನಮ್ಮ ಮನಸ್ಸು ಸ್ವಲ್ಪ ಚೆನ್ನಾಗಿ ಸಂಕುಚಿತ ಭಾವನೆಯಿಂದ ನೋಡ್ಬೋದು ಯಾವುದೇ ಒಂದು ಟಾಪಿಕ್.
ಹೌದು.
ಅಯ್ಯೋ ನಂಗೆ ಇದ್ ಬೇಡ, ನಂಗೆ ಇಷ್ಟ ಆಗಲ್ಲ, ಅದ್ ಬೇಡ ಅಂತ ಓಪನ್ ಮೈಂಡೆಡ್ನೆಸ್ ಇದ್ರೆ ಅದೇ ಐಡಿಯಾಸ್ ನಾವು ಸೆಲ್ಸ್ ಅಲ್ಲೂ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು, ಮೀನ್ಗಳಿಗೂ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು, ಆಮೇಲೆ ಅದನ್ನ ಈಕೋ ಸಿಸ್ಟಮ್ಸ್ ಅಲ್ಲೂ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ಸೊ ಅದು ಒಂದ್ ರೀತಿ ಪವರ್ ಆಫ್ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್, ಅದು ಪವರ್ ಆಫ್ ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ಥಿಂಕಿಂಗ್.
ಸೊ ಈ ಪಾಡ್ಕಾಸ್ಟ್ ಕನ್ನಡದವ್ರು ಯಾರು ಕೇಳ್ತಾ ಇದ್ರೆ ದಯವಿಟ್ಟು ವಿಶ್ವೇಶ ಅವ್ರ ವೆಬ್ ಪೇಜ್ಗೆ ಹೋಗಿ. ಅವ್ರ ವೆಬ್ ಪೇಜ್ ನಲ್ಲಿರೋ ಇನ್ಫಾರ್ಮೇಶನ್ ತುಂಬಾನೇ ಚೆನ್ನಾಗಿದೆ. ಕೆಲವು ಇನ್ಫಾರ್ಮೇಶನ್ ಕನ್ನಡದಲ್ಲೂ ಇದೆ. ನೀವು ತುಂಬಾನೇ ಆಳವಾದ ವಿಷಯಗಳನ್ನ ಸಂಕ್ಷಿಪ್ತವಾಗಿ ಆಕ್ಚುಲಿ ಬರೆದಿದ್ದಾರೆ. ಚೂರು ಓದಿ. ಐ ಆಮ್ ಶೂರ್ ನಿಮ್ಗೆ ಎಲ್ಲರಿಗೂ ಅಟ್ಲೀಸ್ಟ್ ವಿಲ್ ಗೆಟ್ ಅನ್ ಐಡಿಯಾ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಅಂಡ್ ಆನ್ಲೈನ್ ಅಲ್ಲೂ ಕೆಲವು ಟಾಕ್ಸ್ ಇದೆ ಅನ್ಸತ್ತಲ್ವಾ ವಿಶ್ವೇಶ? ನಿಮ್ ಟಾಕ್ಸ್ ಕನ್ನಡದಲ್ಲಿದೆ, ಅದನ್ನು ನೋಡಿ. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಇದೆ, ನಾನು ನೋಡಿದ್ದೀನಿ. ಇನ್ಫ್ಯಾಕ್ಟ್
ಕನ್ನಡದಲ್ಲಿ ಕೆಲವು ಒಂದೆರಡು ಅದೇ ನಮ್ಮ ರಿಸರ್ಚ್ ಬಗ್ಗೆ ಇದೆ. ಇವಾಗ ಗುಂಪಲ್ಲಿ ಪ್ರಾಣಿಗಳು ಹೇಗೆ ಚಲಿಸುತ್ತೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು ಹೇಗೆ, ಅದ್ರ ಬಗ್ಗೆ ಒಂದ್ 2-3 ಇದೆ. ಆಮೇಲೆ ಕೋವಿಡ್ ಬಗ್ಗೆ, ಅದ್ರ ಬಗ್ಗೆನೂ ಒಂದ್ 2-3 ಕನ್ನಡದಲ್ಲಿ ಇದೆ.
ಅದೆಲ್ಲ ನಿಮ್ ವೆಬ್ ಪೇಜ್ ಅಲ್ಲಿ ಲಿಂಕ್ ಇದೆ ಅಲ್ಲ? ನಿಮ್ ವೆಬ್ ಪೇಜ್ ಅಲ್ಲೂ ಲಿಂಕ್ ಇದೆ ಅಲ್ಲ?
ವೆಬ್ ಪೇಜ್ ಇಂದ ಇದೆ, ಸುಮಾರು ಇದೆ. ವೆಬ್ ಪೇಜ್ ಮತ್ತೆ ಯೂಟ್ಯೂಬ್ ಚಾನೆಲ್ ಇಂದ ಇದೆ, ಎಲ್ಲದಕ್ಕೂ ಲಿಂಕ್.
ಓಕೆ. ಹಾಗಿದ್ರೆ ಅದನ್ನು ಲಿಂಕ್ ಮಾಡ್ತೀವಿ ಶೋ ನೋಟ್ಸ್ ಅಲ್ಲಿ, ನೋಡಿ ಎಲ್ಲರೂ. ಓಕೆ, ಈಗ ನಾವು ಲ್ಯಾಂಗ್ವೇಜ್ ಸ್ವಿಚ್ ಮಾಡ್ತೀವಿ. ಸೊ ವಿಶ್ವೇಶ, ಎಕ್ಸಲೆಂಟ್, ದಿಸ್ ಇಸ್ ಔಟ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ರಿಯಲಿ. It's also much easier if two people are speaking the other language, because I've seen some of my guests earlier had a slightly tough time to speak in their mother tongue only as a individual conversant. Here it's much easier to converse between two people. So finally, we will kind of almost coming towards the conclusion of this episode. Before that, I would want you to let us know your kind of broader plans going into future. What are the kind of projects you want to take up, and what initiatives you want to take in both research and teaching. If you could just give us an overview, that would be great.
So, I mean, it's a difficult question. What's the broad overview and future plan? It requires a lot of clear thinking. Thanks for asking this question. So I think, one of the goals we are really interested is sort of understanding. As I said, we have two broad themes of research. Right? One I have explained a bit more. The ecosystems and stuff. The other topic we are very interested in relates to what I first started with, how animals move in groups. So one thing we are really interested is, what are the mathematical signatures of these animals that move in groups? Are there some, is every species different? Okay, of course, every species is different. Okay, but every individual is different. Okay? But still, when you put them all together, there are some common emergent properties. Okay. So
Yes.
this is
Yes.
something everybody agrees. We already know these things. Okay. But can we go a bit further and say, can we say, are there more precise mathematical formulations of
Mm.
these animals that move in groups? Okay. Now, we want this mathematical formulation not to be written only as an equation. We
Mm.
want
Mm.
these equations not from you and me. I want
Mm.
these equations to come from the data.
Mm. Mm.
For
Mm.
example, what is the equation that a group of fish are following?
Mm.
If I gave you a video of fish, can you sort
Mm.
of tell me what's the equation that they're following? If I
Mm.
gave you a video of fish, or if I gave a video of birds, flock of
Mm.
birds, okay? And if I were to somehow magically get these equations,
Mm.
okay, will they be all different? Will every species have their own equations that they are all following? Or there will be some common features
Mm.
that
Mm.
transcends species.
Species. Mm.
Okay.
Mm.
Yeah? And that's the broad framework that we are thinking about.
Mm. Mm.
So what we think
Mm.
is probably the reality is that although every individual is different and every
Mm.
species is different and therefore every
Mm.
group is also different, all of these at the group level will fall into some buckets. So
Mm.
we will not
Mm.
have infinitely large number of buckets, but maybe
Mm.
a handful of them. So we can sort of mathematically characterize their collective motion just
Mm.
using a few of these buckets.
Mm.
Okay. So
Mm.
we are now trying to sort of develop both theory and sort of understand, discover these buckets of
Mm.
broad classes,
Mm.
entirely based on data.
Mm.
Okay. So we are using these sort of very new methods, and we are developing our own methods called data-driven discovery of equations. The idea is that I don't tell what the equations of that these systems are following, but let the data tell me what are these equations.
What are the equations? Very
So
nice. Very
okay,
nice.
so we are using these ideas called physics-inspired machine learning, where
Imagination.
we
Uh-huh.
sort of keep the physics part of the machine learning really intact,
Mm. Mm.
but we still use some power of the machine learning. But we sort
Wonderful.
of constrain them with the sort of physical principles and biological
Mm.
principles, and
Mm.
don't make
Mm.
it a black box. Usually, machine learning is a full black box, right? But we are
Yes. Yes.
trying to make them interpretable.
Mm.
So we are using those tools to sort of discover the broad, unifying features of how animals live in groups, how animals move in groups. So that's sort of
Wonderful.
one broad question we are really interested in. So
Mm.
despite the diversity, what are the unifying principles? Is the
Nice.
broad question that we are really interested in.
Wonderful, wonderful. So it also means that you would be mainly looking at problems from an ecosystem which already is larger in scale, or
Mhm.
are you also interested in scales which are very small, for example, which can be microbial and other things? Mm.
It could be any scale. It doesn't,
Mm.
scale is sort of, the initial
Y-
unit can be anything. It could be
Anything.
microbes, it could be
Mm.
fish, it could be
Mm.
trees, it could be any of these.
Yes.
Okay.
That's the power of
So
modeling also.
yeah,
Yeah.
absolutely. Although we are sort of trying to focus right now, a lot of our current studies are focusing on fish schools for the time being.
Mm, mm,
Okay, but in principle, it can be any
mm.
organism. It doesn't have to be a specific organism.
Very nice. Fantastic. Fantastic. I wish you all the best for all the future ventures. And I am very sure this will also be first of a few more conversations which we're going to have to expand on a lot of things what we have discussed in this podcast. Because you can see that a lot of things what we have discussed probably is touching the surface, so to speak. And given that the podcast is also moving as some kind of a mini oral history series, I would come back to you at some point of time to kind of so-called double click on the few points what we have been discussing. So I'm extremely thankful to you, Vishwesha, for a wonderful conversation, and it's been a pleasure, absolute pleasure. Mhm.
Yeah, no, pleasure is really all mine. Thank you so much for inviting me and spending so much time trying to understand, trying to talk
My
to me
pleasure.
about what we do in the lab. It's really, really an honor. Thanks for inviting me. And you're
Yeah,
doing such an amazing job talking to all these so many different people and sort of documenting
yeah, yeah.
their way of thinking. I think I'm sure you're also now discovering some commonalities, yet
Patterns.
some
Yeah,
patterns
yeah,
emerging
yeah,
out in your
yeah.
mind. It must be
Yeah,
really
I'm
fascinating.
actually I'm a formal student of physics. I'm an informal
Mhm.
student of history. I keep telling that,
Mhm.
and
Mhm.
ever since I was a student, I have always been fascinated by histories,
Mhm.
biographies,
Mhm.
and other things. So this is
Mhm.
just a kind of a learning process for me in that sense, also,
Mhm.
so to speak. And this is
Mhm.
giving me a good opportunity to learn more in that sense.
Mhm.
So thanks
Okay.
again, Vishwesha. Thank you very much. This is Pratidwani, where we try to humanize science with the Vishwesha Guttal.
Thank you. Bye.
Thank you.